Okay, all good. And we start the session now. Welcome back, everyone, to the Data Science Summer School 2025. This is the last sessions for the Data Science Summer School this year, and I think quite a few of you have already attended the workshop this morning on statistics and probability theories, and welcome back. If you're new here, then welcome, a very warm welcome to you for joining us. The summer school is organized by the Hertie School Data Science Lab together with the generous support of the Hertie School and the Digital Foundation. It brings together a series of theoretical and hands-on workshops led by expert researchers and professionals working at the intersection of data science, public policy, and social impact. A little bit of housekeeping. Everyone in the session has your microphone and video turned off as we have quite a large audience here. And you can put your questions in the chat or in the Q&A here, and our instructors will try to answer them when you can. We also have Aliyah who will support the sessions with the Q&A as well. And today we turn our attention to one of the most pressing questions in social science today. How does digital media influence attitudes and behaviors and political outcomes? And how can we study it rigorously? Right? And this workshops will introduce you to the fundamentals of experimental design in the context of digital media research. You'll learn how to formulate the research questions and develop a testable hypothesis, and maybe design experiments tailored to online platforms or online survey environments. And we explore some concepts like randomizations and treatment assignments and causal inference to give you a practical toolkit to study online misinformations, algorithmic influence, and digital campaign effects. And it's my pleasure to introduce our instructor today, Dr. Kevin Munger. Dr. Munger is the assistant professor and chair of computational social science at the European University Institute in Florence. And he uses cutting-edge computational experimental methods to examine how social media and the internet shape political informations and communications. And his work has been published in leading journals such as Nature, American Journal of Political Science, and Journal of Communications. And he's also the author of two books, Generation Gap, Why the Baby Boomers Still Dominate American Politics and Cultural, and the YouTube Apparatus. And in 2021, he co-founded and became co-editor of the Journal of Quantitative Description, Digital Media. His current research spans platforms from TikTok to Twitch, as well as the philosophy of social science, bringing the deep analytical lens to study of democracy in the digital age. And so please join me in giving a very warm welcome to Dr. Munger, who will be your instructor today. To you, Kevin.
All right. Thank you very much for that very kind introduction. I did not realize that some of you all had already been in a session today, so I definitely appreciate the commitment to learning. And for those of you just joining, also, I'm excited to get to share with you something that I've been working on for about a decade now. Crazy as that is to say, I guess, that indeed social media has been an important force in politics, political communication for at least that long. And today I will be talking about a lot of the lessons that I've learned in conducting experiments on a number of platforms, ranging from Twitter to WhatsApp to Instagram and Twitch and TikTok. So a little bit, we just heard a very brief introduction, but in terms of my background and my trajectory for how I got here, I started out studying math and then got my PhD in politics and got interested in at NYU, the confluence of two different trends in contemporary social science. So some of you might be aware, NYU is the home of the Center for the Study of Social Media and Politics, which has been one of the leading locations for the rigorous use of computational social science tools to understand social media. And when I was in grad school, I came to appreciate the importance of social media, and in combination with the newfound attention to two methods that have really become central to social science. One of them is experiments, which is the topic of today's lecture. And the second is computational text analysis. So This is a related theme, perhaps in some of the other lectures in this series. You've seen some of the approaches of studying text as data. It's also very clearly the case that there's been a revolution in the use of LLMs for studying text data. But the combination of these three things we will see allows us to understand what social media is, how it is relevant for politics, to intervene on social media to conduct these experiments. And then in many cases, what we're going to be doing is using quantitative text analysis to transform the text of a post or a comment or a description of a post into some kind of outcome variable that we can measure. So the way that I have been working really throughout my career has been by combining these three theoretical and methodological approaches. So just to briefly talk about some of the themes that I've been interested in and what we'll talk about today, the way in which political communication has been transformed in the digital age, the combination of experimental and computational methods, the importance of platforms, and in particular, when it comes to studying misinformation through the lens of digital literacy, which we'll talk about for quite a bit today. And one of the most unique problems when it comes to studying social media, either with experiments or with any other method, is the problem of temporal validity, which is the fact that the thing that we are studying changes very quickly, and this causes lots of issues for the standard approaches that we use to study it. As I said, I've taught courses in all of these methods in substantive areas, and today really represents the synthesis of a number of courses and research projects that I've conducted throughout my career. So, given that I understand there's a variety of backgrounds, I don't want to give a full course in statistical methods for understanding experiments, but I also don't want to leave anyone behind who maybe has never heard of never really analyzed an experiment before. So I'm going to give a very brief overview of the methodology that we're interested in here, just to make sure that you're familiar with the key terms. And we can certainly go into more detail if you have any questions, but I'm assuming that this is going to be a reminder, or at least enough for people to follow along when we talk about the several case studies that represent the bulk of the lecture. Okay, so why should we use experiments in social science? I mentioned the importance of causal inference, that one of perhaps the central goal in social science is to understand how one thing affects another thing in the social world. And over the past 20 or 30 years, we've really come to appreciate the limitations of observational studies when trying to make causal inferences. So if we simply look at the correlation between two different variables of interest, this is not going to be sufficient for identifying a causal effect. Even the use of more sophisticated statistical models or a lot of different control variables is not enough to really rule out the possibility that there is some unknown third factor which is causing the observed relationship. And so the standard justification for why we like to do experiments is that they allow us to make stronger claims of causal inference because of the power of randomization. So when we are the ones doing the randomizing, we're very confident that it's our randomization which is producing the different results in the different groups. And so I'll talk about that briefly, but really the element that I find most exciting about experiments and what has really motivated me is the fact that it is the only method which really allows us to take actions in the world. And insofar as our goal is to understand the social world, I think it is important to understand the relationship between actions we can take and the results of those actions. So it is interesting to learn theoretical results. Certainly, much of the conversation today will focus on the specific theoretical inferences that we draw when we run experiments. But what I think is most unique about this method is that it allows us to figure out what type of actions we want to take in service of getting us from the world we're in to the world we want to be in, right? And so social media is a new field site. When we talk about running field experiments, and I will spend some time distinguishing the difference between field experiments and lab experiments, social media is a new kind of field experiments, which allows us to operate at unprecedented scale with unprecedented speed, but which also has this drawback of being dynamic. And so it is changing very quickly. Perhaps it is changing faster than we are able to study it, which represents a new kind of problem that we haven't really encountered in some of the more traditional field experiments when it comes to development economics or other contexts you might be more familiar with. Okay. So yeah, I think we were told about the structure here, but I'm going to give, I think, 3 separate lectures, and then there'll be time for Q&A. So I saw some comments, but I will just proceed until we get to the Q&A sessions. If you have some particular point of confusion, I think you can reach out to Aaliyah, and then she will tell me so I can sort of proceed with the lecture without checking the comments the whole time. So, okay, the social media context, as I say, is novel, and it has some advantages and disadvantages. So many of the phenomena of interest to social science are more naturally visible in this context. So when it comes to information diffusion, the study of social norms or political influence, much of this traditionally has happened in face-to-face encounters or through the individual consuming some kind of political media. And it's very difficult for social scientists to actually track the way in which information, norms, travels throughout a network. Whereas on social media, and particularly network-based social media, this is really built into the architecture of the platforms. And so from network science perspective, especially, it's been very exciting to actually get to trace the evolution of these fundamental social processes, which otherwise would have been hidden. This is also a place where the social media platforms are running many experiments themselves. So usually they don't really call them RCTs or randomized control trials or field experiments the way that social scientists do. If you're coming from a computer science or a management science perspective, you might be more used to hearing about A/B testing. And this is a sort of different type of experimentation, which has different goals. I will talk about this briefly during the lecture, but the primary focus here is going to be on the traditional social science theoretical goals. And so I think that even if you are interested in more applied experimentation, there's a lot that we can learn about how to design experiments for both of these goals. The new power to explore these social processes online has been very exciting, but it presents novel ethical and technical considerations that we otherwise just wouldn't have had the power really to do. So social scientists have traditionally been very limited in terms of our ability to conduct experiments because they're very expensive and we don't have that much money. But now, either by collaborating with the platforms or by using automated interventions, we have the capacity to really intervene on social processes at scale that we did not before. And that is exciting, but it has some serious ethical risks. So we will be, with every of the case studies, we will spend quite a bit of time thinking about the ethics. And I am there's different schools of thought here. I'm generally pro experimentation, obviously. It's what I do for most of my job. And so I think that there is a good ethical case for running a lot of experiments. I'm not someone who says, well, we should never be doing anything unless we have, full informed consent from every single user. First of all, because the platforms never get that when they are running their experiments. And second of all, if the experiment that you're running is going to cause good things to happen, I think that we should be trying to do good things in the world. And as long as we are taking sufficient caution to avoid any kind of privacy violations or possible harms to the research subjects, I think that the knowledge that we gain from experimentation is worth the risks. And so finally, I think that it is just kind of more fun to run experiments than it is to analyze existing data sets. It first of all allows us to see when we take actions, all sorts of unexpected things happen. So we're going to be focusing today on the statistical results of the experiments that we conduct. But a lot of the things that I found most interesting in my own career about what I've learned from experiments are things that are unexpected, things that don't show up in the statistical results, simply because when you do stuff in the world, interesting things can happen. And so this doesn't really mean that any experiment is going to be the final word on the topic you're studying. Instead, it's part of an ongoing process where when something unexpected happens, that reshapes our theoretical understanding of what's going on in a way that we can't really be as surprised when we're analyzing trace data. Okay, so very briefly, going through causal inference basics, just so that when I talk through the rest of the case studies, we can be on the same page terminologically. So the goal of causal inference is to estimate a causal effect of a treatment on an outcome. So in order to do that, we're going to have to define what the treatment is and what the control group is. And as we will see, this is necessary because we can only ever do this on average. We can never observe the effect of the treatment on a single unit. And so I will just very briefly walk through some potential outcomes framework. This is, in my opinion, the dominant framework for understanding causal inference. There's also the directed acyclic graphs, or DAGs, which I will talk about very briefly during one of the presentations. But the main way I think we should think about causal inference is from the perspective of the potential outcomes framework. So very simply, what this means is that every unit, every user, let's say in an experiment where we're studying social media users, has two different outcomes. These outcomes are defined in advance, and we're going to observe one of those two outcomes, y1 if the unit is treated, y0 if the unit is in control. So the true causal effect for a given unit I is just the difference between their outcome under y1 if they're treated and their outcome under y0 if they're in the control group. But again, we can't observe both of those for any given unit. Each unit is either going to be in the treatment or the control. And so what we do with randomization is estimate the average treatment effect. So because we are confident that we are dividing the subjects, the units, into groups, treatment and control randomly according to some procedure that we control, that the only difference on average between the observed outcomes for the units in the treatment group and the control group is because of the randomization. And so we can be confident that by comparing these means, we will have estimated the average treatment effect. So if we don't have randomization, there's always going to be some potential confounders between the independent variable that we're interested in and the outcome variable that we're interested in. Because of randomization, we can be confident that groups are on average statistically equivalent. And so we are able to get an unbiased estimation of the treatment effects. Sorry about that. This is just the average difference between the units in the treatment, and in the control is the estimated AT. Okay, so that's going to be the majority of the statistical formulation in the presentation. We'll come back to it at a few points, but that's about as deep as we're going to go here. I don't want to scare anyone off, but it's very helpful to have access to this terminology. In terms of more natural language, which is how we're going to approach experimental design primarily, there are certain components of an experiment that are essential. The first are the units. So what exactly in your experiment is the unit of interest? Generally, it's going to be users if we're studying individual people, but it even could be individual posts. So not focused on the user, or we could be focusing on communities. A lot of the experiments on Reddit, for example, are focused at the community level and what's happening in the conversation overall. I think the most crucial, most interesting component has to do with defining the treatment and control. So what exactly is the intervention that you're going to take, and what is the non-intervention that you're going to take? It's equally important because the treatment effect is only going to be defined by comparing the treatment and control. It's very important that we come up with some good reason that the control group is a true control group and not simply another type of treatment. And I think this makes more sense when we look at the different examples. The randomization can be done with simple randomization. There are many different applications in coding statistical software for running the actual generating the randomization procedure. Many of the experiments will also use a more sophisticated randomization procedure, which I'll talk about on the next slide. So equally important is the definition of the outcome variable. And so in some of the more traditional field experiments, the outcome variable is, did someone turn out to vote? But in a lot of the experiments that we're interested in, this is going to be either on an online survey or the behavior on an online platform. And so we're going to have to do some kind of engineering to transform what is often just something that we get from the social media platform API in terms of the text, perhaps, or some type of behavior into the outcome variable of interest, according to the theory we're interested in. Two components which are increasingly central, which it's kind of funny, during my 10-year career at this point, pre-registration and a pre-analysis plan were quite rare, and now they are pretty much mandatory. And this is a set of tools that mean that we are not going to be basically p-hacking. We're not going to run the experiment and then look at a bunch of different outcome variables and only report the results of the ones where we get a statistically significant result. So some people think of this as punishing or constraining. I think actually it's really just helpful for thinking through the experimental design in advance. Because again, when you run the experiment, all sorts of unexpected things are going to happen. But for the rigor of the central estimate of interest, it really benefits from putting as much thought as you can in upfront to figure out what are some different types of how are you going to transform the data, how are you going to analyze it, such that everyone else who reads your paper is going to be very confident that you've done the right thing and that you have not fished around for some kind of lucky combination of variables, which gives you a significant result. Okay, so I mentioned briefly when it comes to randomization, the simple randomization design is the completely randomized design that if you have two treatment groups, let's say, you essentially flip a computational coin and each unit gets assigned individually to treatment or control. One of the downsides of this is that although randomization has the nice feature that in expectation, all of the units in the treatment and control are the same, if you don't have that large a sample, or if some covariates are really quite important. So if you think that your treatment is going to have very different effects on young people and old people, which is something that we do find a lot in social media, it might be the case that on average, one of the groups has slightly more older people, and that might be driving your results. So the use of blocked or stratified randomization, it's a technique to say we're going to identify the variables that we think are most important for understanding the effect of a treatment. And then when we assign people to treatments, we're going to make sure that although we're randomizing each assignment, it's not purely random, such that we end up with, we're confident that on those features of interest, we have the same number of people in the treatment and control group. We might also have cluster design. So particularly, I think in Reddit, it really is the most common social media case. You can assign treatment at the level of the community, such that even if the individual unit of analysis is a single person, it might be the case that you're not able to fully randomize because everybody in a community gets the same treatment level. And so this is a way in analyzing the experiment to make sure that the standard errors are correct. It's a somewhat more sophisticated problem, but it's worth mentioning here. And then factorial design, simply if you have many different treatments, how are you going to balance them? We will talk about this when we get to a discussion of a conjoint experiment. The most basic way of thinking about this is, let's say that we have an experiment. We want to understand the effect of misinformation flags. So we're studying the effect of misinformation, and we want to understand whether or not adding a flag at the platform level allows us to change the effect of misinformation. And so we're going to show some people the misinformation. We're going to show other people misinformation with the flag. And so here we would be assigning the treatment at the level of the individual post. One more really important component of experimental design on the statistical side of things is a power analysis. So this is again something which has become much more prominent in the past decade and now is mandatory. We need to make sure that we have a sufficiently large sample size in order to detect the right kind of effect. So one of the problems that produced the replication crisis, which perhaps you all have heard of, is that people were running too many experiments with a small sample size. And so they were getting a number of false negatives. And when it comes to the publication process, because we're only publishing significant results, this leads to publication bias. And so you need to have a sufficiently large experiment in order to detect the right kinds of effects. There are many different power calculators online, which allow you to calculate the required sample size given a given effect value. That's something that you need to make sure you're doing in addition to the pre-analysis plan, but we're not going to get into the details of how to implement that. There are many different, web-based or R packages that allow you to do this well. Okay. So at a more conceptual level, we're going to talk about two different types of experiments for studying social media. I've already mentioned the idea of social media as a field site. And so we're going to be talking about this as a field experiment, where it is an experiment conducted in a real world, naturally occurring setting. It is ironic, I think, to describe social media as the real world. In many cases, the internet and social media is explicitly contrasted with the real world. But in terms of how people actually experience their lives and are conducting politics, social media is the real world. And it is naturally how people today are going about the business of getting informed about politics. So when we're doing an experiment, a field experiment, the participants are often unaware that they're in an experiment. So this does produce a higher level of ethical concern. I think it doesn't mean these experiments can't be conducted, but it does mean that we need to be more careful. And the key advantage here is, I like to talk about it in terms of ecological validity. And we're going to talk about a number of different types of validity today. And much of experimental design is based on figuring out how to do things with higher levels of validity. But one of the lessons I think we're going to take away is that there's always trade-offs in terms of the different types of validities. There's not one single perfect experiment or research design. And so the key advantage of the field experiment is that it's higher in ecological validity, that when we're studying this process in the real world, we are much more confident that the intervention that we're taking is something that actually would work if other people were to implement it. And so this is contrasted in the lab experiment or the survey experiment, which we'll talk about in a second. And so I think that social media has some features of a field experiment and some features of a lab experiment. And I think that this actually means that we can do different types of experiments that people were never able to do before, and I'm quite excited about that prospect. So um, that's laying the groundwork for getting the terminology together and making sure we're kind of on the same page about what exactly an experiment is. And so I will turn now to the first of many case studies. And this is really one of the first, I think the first big social science, social media experiment. It's the Facebook voter turnout experiment conducted by Bond et al. In 2012. And this was a real world experiment. They were interested in whether social messages on Facebook increase voter turnout. They had a sample size of 61 million users, which is really extremely large. And they were randomly assigned to see either a social or an informational message. So we're going to develop a kind of formula for thinking about experimental design. And so in this case, the users are the units of analysis. The treatments are, is it a social or informational message? And the outcome variable is self-reported voting. So on Facebook, there was a feature for people to say, click a button and say, I voted. And one of the most impressive parts of this experiment is that they compared the people on Facebook who were part of the experiment to a real voter registration, voter turnout list to measure real world voting. They find actually that social messages have an even larger increase than the informational messages because of social contagion. So that's kind of abstract. I think looking at the key figure here will let us understand what exactly happened. So on the left, we see the different treatments. The informational message is a button that popped up on Facebook and said, find your polling place in the US. It's a way to just remind you that today is the election day. It lets you know where the voter turnout place is. There's a counter here for how many people voted according to Facebook, how many of them clicked this button, and then you get the chance to click this button. So that's the informational message. Then we have the social message, which has all of that information, but it also has specific information from your Facebook friends. So we see here, these are the scientists who conducted this experiment. We see their profile pictures, and then we see that these are individual people that the user, the subject knows, and that they reported turning out to vote. So, according to the theory of social norms, social pressure, this should have a larger effect because it's not just some abstract people turning out to vote, it's actually people you know. And in fact, they do find this. So we see that the effect of the informational message was actually quite small. And according to these different outcome variables, we see different levels of significant results. There's a huge effect on self-reported voting. But that's really, this is a lesson of the limitations of having a self-reported outcome variable in your experiment. Because in fact, when we compare that to validated voting, how many people, according to the actual voter turnout lists, voted, this effect is dramatically too large. But we do see that there is a significant increase in the voter turnout according to the social message compared to either the control group or the informational message group. And if you just think about the numbers here, this means that about, I forget the exact number, but hundreds of thousands of people turned out to vote as a result of this experiment who otherwise would not have. Okay, so this is kind of, I think it was very inspiring. It was definitely a big deal when it came out at the beginning of grad school for me. But I think there are also a number of issues with this experiment. So I guess just based on what I've discussed so far, can anyone think of some issues with this experiment? Just post them in the chats or if there's any thoughts on this. Yeah.
Hi, Kevin.
Hello.
was a question from Anna Kravitz, I think, about the social experiments or ethical issues, experimenting with voting, or Ildar Deminov is writing, there may be other factors impacting turnout during a specific election. Alexander Popov writing ethical issues, experimenting with voting. Margaret Nansubuga wrote, it assumes that everyone has access to a computer.
Yeah. That's great. So that's good. For now, I can look at the chat here. So yeah, ethical issues with voting. I think that's absolutely a big concern here. If anything, maybe the problem is that the experiment was too large. So they got 60 million people, and they probably didn't need that many. And so this is a trade-off with the power that we now have when we're conducting these experiments versus how many do we really need. And so I think that we should try to avoid doing anything that might change the outcome of an election. And there's a trade-off there with doing the experiments because the knowledge that we gain is valuable. But I think that we have to be very serious if we're going to be doing a treatment that affects 60 million people. So it's definitely the case that there are other factors impacting turnout during a specific election. But this is kind of the upside of the experiment itself, is that on average, because we've assigned the treatment and the control, when we're looking at the difference between the treatment and control, that should be a way to get rid of most of those other factors. So it's always possible there's something else going on here, but this is the kind of key advantage of randomization, is that we are confident that the difference between the treatment and control is going to be driven by us assigning them to the treatment. And then, yeah, so assuming everyone has access to a computer, this is I would say, a version of the concern about the sample. So we're only studying people who have Facebook accounts, and we don't necessarily know what the effect would be on people who don't have a computer or don't have a Facebook account. And so this is a general problem with any kind of experiment, is to really think seriously about what is the population of interest, and does our sample do a good job of capturing that population of interest? In terms of the bots, I think that this is definitely, I think that the most social media experiments have the problem of dealing with bots, and we will certainly see a bot experiment in a second. I think that so for the self-reported outcome, that's a problem. But what is unique about this is that they are able to compare this to the real world voting. And so I think that at least that part of the experiment should be robust to any kind of bots. And then, yeah, so if we were to have the data from a social media platform, well, how could we be confident they did it right? That is definitely a problem, and we will talk about this in the case of, hopefully we get to a discussion of Upworthy. And in general, that's a problem when we get data from social media platforms. We do have to trust, even if we're not doing an experiment, that when we put an API call and we say, give us all of the posts from this time and this place, that it does it correctly. And that's generally a limitation of relying on data from social media platforms. And then, yeah, so this is the last one here. I would say one of the issues is Facebook users might not always click on pop-ups like that, even if they did vote. And so this ties quite nicely into one of the main concerns I have, which is that I think in 2012, right, this was a very long time ago, and this was a very unique treatment. So Facebook at that point really did not have very many pop-ups. So I think that at the time, it was as if all of the TV stations had a banner at the bottom. You turn on TV, every Netflix show had a banner, today is election day, and there's never any other banners. And so that's a very powerful treatment. But over time, Facebook has gotten, and many other social media platforms, they've been a lot more ads, it's a lot more busy, there's a lot more pop-ups. And so I think if you were to do the same experiment today, people would not be able to pay as much attention to this specific pop-up. And so the treatment effect that we observe at this point in time was really because the treatment was novel and Facebook was not very busy at the time. And so this is a limitation when we think about moving forward and taking the results of this experiment. And if we were to do the same thing today, I think we might get quite different results. Okay, so that's great. Thanks for chiming in there. And that lets me introduce the formula that we'll be talking about for every case study today, which I think will be helpful for you thinking about how you should design social media experiments. Okay. So the first thing is to define a theory. That's if we're doing a social science experiment. And I think that's the main thing we're talking about here. It's a timeless goal of social science. So the experiment is producing theoretical knowledge. We're going to publish this in a paper in an academic journal because we want to contribute to scientific knowledge. The other goal, is implementation. So some experiments are sort of simpler than this, and we are only conducting the experiment because immediately we want to know which action the experimenter should take right now. And so for a lot of organizations, companies, political campaigns, they actually aren't that interested in theory. They just need to know which of these different political ads will get the biggest fundraising impact. And so that's a different goal. We'll talk about it a little bit, but primarily we're thinking about the theoretical goals. So the problem of temporal validity, which I mentioned, is something we have to think about all the time when we are designing these experiments. We are engaged in the philosophical task of induction. And the problem of induction is that all of our knowledge is from the past, and all of the knowledge that we want to apply is in the future. So there's this issue where there's a gap between what we've studied and what we want to take action, which is in the future. Academic research takes place as time advances. It takes many years to get a master's degree and a PhD. It takes many years to actually publish a paper in an academic journal. All the while, we are seeing the digital world in particular change very quickly. So as we are doing these internally valid studies that are, perfectly randomized, there's no issues with the measurement, whatever, it's perfect. But even still, the world is changing. And so this is a limitation of our ability to take the knowledge from the past and apply it to the future. In general, I think that the systems which change the quickest are the ones which have the most acute version of this problem. I call it the knowledge decay parameter. How quickly does the knowledge that was generated in that 2012 experiment decay compared to a physics experiment, which is just as valid today as it was 100 years ago? And so a kind of thought experiment here, which illustrates the problem. If you're reading a literature review, you might say, find a sentence which says that this author in 2015 found that using Facebook increases political knowledge. But this other author in 2022 finds the opposite, finds that using Facebook decreases political knowledge. And in traditional scientific practice, we would like to say, okay, well, these two competing findings, what we're going to do is do more research, and the future research will adjudicate which of them is correct. And of course, I think that's nonsense in this case, because Facebook in 2015 was just a different thing than Facebook in 2022. And if we did another experiment in 2025 and we found a third thing, that would not tell us that either of the first two things were wrong, simply that Facebook itself is a different thing now. And this is a unique problem to studying social media with experiments. And so that's why I want to spend some time highlighting it. Even if you're interested in immediately applying the results of an experiment, temporal validity is an issue. So I got ahead of myself before, but this is the formula that we will be working with for designing a theoretical experiment. These are the questions that I think you need to be able to answer when you are engaging in experimental design. The first question is, what is the theory? If the goal is to enter into some kind of theoretical conversation, you need to be confident about what theory you are trying to test. The second is, where do we have some power in the world? And what I mean by this is, I'm just a person. I can use the internet like a normal person, but to conduct an experiment requires organization, it requires resources, and every person has different sets of resources, and different platforms give us different affordances. So a lot of the times, the way that we're going to have some power is we have some money, and we can use the money to conduct research. We can pay for people to take our surveys. We can pay for RAs to analyze data. We can collaborate with an organization which is going to actually implement the randomization. As I will show you in some of my earliest experiments when I was a grad student who didn't have any money, we can actually, a lot of times on social media, actually do the interventions ourselves. And I think that's kind of an inspiring point about this type of research, is that it's actually possible to run an experiment essentially for free by yourself. It takes a long time, but it is possible, and you can still do things that you could not if you were trying to do an experiment in the physical world. Given that I think the most interesting part of the experiment is the description of the treatment, we're trying to learn about the theory, what we need to do is figure out the exact relationship between the treatment that we're trying to implement and the theory of interest. When it comes to defining the users, the units of analysis, the first thing to do is think about the population of interest. What type of units are we interested in studying? And then we also need to figure out we're not going to be able to observe the population. We're going to have to take a sample of the population. And is our sample good enough representative of that population? I'll think about how to answer that question. When it comes to the outcomes of interest, we have to decide what exactly we can measure. A lot of this is going to be survey questions or digital trace data about people leaving posts. And then, of course, we need to figure out how our measurement, again, relates back to the theory. And finally, we need to think about, is it ethical? And we'll talk about this in many different cases. Okay, I will take a sip of water, and we will talk about my Twitter bot experiments. Okay, well, so Twitter, which existed until 2021, now it's X, is a very important platform for political communication. And here's an example of that political communication. This is the first social media experiment I conducted in my career. And so I think it's a nice, ideal example animal for thinking about experimental design concerns. It's pretty straightforward. So in the 2016 US presidential election, we could see a tweet from presidential candidate Donald Trump. And then we have a response from this user, NSA agent Jim. And then we have a response from Sean. And so we see here a kind of paradigmatic type of communication where we have someone who I assume is anti-Trump saying, "I hope you die." And then we have someone who is pro-Trump saying something equally nasty to NSA agent Jim. And so this is a kind of uncivil political conversation, which has come to define political communication on social media, but especially on Twitter. And so my goal in conducting this experiment was to try to reduce incivility to produce healthier conversations online. So Matthew here is a bot that I controlled. And Matthew says you shouldn't use language like that. Republicans need to remember that our opponents are real people with real feelings. So we see here, Matthew, I'll talk a little bit about the design of the intervention, but Matthew has a Republican sticker on his profile picture. He identifies as a Republican, and he's trying to get Sean to not be uncivil to his political opponents. So this is the basic design of the experiment. And so thinking about our formula, we'll take a second at the end of this discussion to think about how this fits into the formula. The research question is, how are norms of online behavior enforced? So the treatment is the use of bots. So here, this was, again, me as a grad student, I did not have any money. I set up sock puppet accounts on Twitter. I was the one doing all of the tweeting. I logged into the accounts, I sent the messages, but I had a number of different bots that had different identities. And the messages that they sent were not identical in every case. And the goal was to see how, when I sent messages from bots that shared the partisan identity of the subject, different types of language affected their subsequent behavior. So randomizing the messages that the bots sent, varying the type of rhetorical appeals to the subjects. The outcome measure here is, again, it's going to be based on text analysis. I scrape all of the messages, all the tweets from the subjects to see if their behavior changes and the treated subjects send fewer uncivil tweets, and whether that varied based on what type of message they received. So we might also be interested in heterogeneous effects. So were the Republican subjects changing their behavior more than the Democratic subjects, or was it the case that more anonymous subjects were changing their behavior more or less? Right. So a little bit about the theory here, because we're going through all these case studies. You don't have to know that much about the theory, so I just want to gesture towards this. Why do we care about incivility? Well, the idea is, from Mutz's paper, is that following the rules of civility or politeness is a means of demonstrating mutual respect. Theocaris et al. Argue that there are incivility is an impolite remark with direct democratic consequences, represents an uncivil tweet. So the idea was, in the 2010s, there was a lot of concern about online incivility producing partisan polarization. Frankly, I think these concerns have been borne out. That I think that as a result of a decade of lots of really nasty tweeting, we have seen increasing partisan polarization. But that was why we were trying to reduce partisan incivility during this time period. So we define incivility as a personal attack. The goal here is close to trolling, right? So the goal is to anger your interlocutor or upset them. You're not really interested in having a discussion or understanding their point of view. We're interested specifically in cross-partisan incivility. So this is when one member of the Republican in the US, we have the Republican and the Democratic Party, right? If a member of the Republican Party is being uncivil to a member of the Democratic Party, that's cross-partisan incivility. And so the other theoretical component is the way in which we define the treatment, right? So we need to have some justification for the relationship between the theory of interest and the specific implementation of the treatment. So in this case, I used Jonathan Haidt's moral intuitionist model. So different types of rhetoric appeal to different moral frameworks. So some people, like conservatives, care more about certain moral frameworks, and liberals care more about other moral frameworks. So the idea was that conservatives would be more affected by the authority moral foundation. And so the way that I operationalized the authority moral foundation was to say, you shouldn't use language like that. Republicans need to behave according to the proper rules of political civility. So there are proper rules. We should follow the rules. The moral foundation that should have been more effective for Democrats was to say, based on caring for people. So you shouldn't use language like that. Democrats need to remember that our opponents are real people with real feelings. And then I included a placebo message. So this is a big part of experimental design, right? We talk about there's a true control group that did not get any messages, right? But we also, if we're interested in understanding the effect of these moral foundations, we might want to have a non-moral message. And that was, remember, everything you post here is public. Everyone can see that you tweeted this. Perhaps that actually came across as a bit of a threat, but we'll see how the results vary. So I pre-registered formally my hypotheses. The first is that the messages sent by bots will cause subjects to engage in less incivility. That was correct. So I mentioned here that this was pre-registered through, in this case, it was eGAP. eGAP is an online repository for pre-registration. I think now the more common repository is the Open Science Foundation. So if you're interested in doing a pre-registration, which I think you should be if you're going to run an experiment, I would recommend using the Open Science Foundation. I also pre-registered that the effect of the care condition will be larger for liberals than for conservatives, and the effect of the authority condition will be larger for conservatives than for liberals. Did not find that. But this is the nice thing about pre-registering my hypothesis. I wrote down in advance what I expected to happen. I did not find it, but that's okay for publishing the paper. I don't only have to publish positive results because I pre-registered it. And if people think my theoretical argument is good, we still learn something when we get a null result, when we don't find what we expected. And yes, we'll talk about some of these other results, but I don't want to get too bogged down in the details here because I think what's most interesting about this is the justification for the field experiment. So a lot of the experiments about counter speech or social norm enforcements had been, to this point, done in a laboratory. And this has a lot of limitations that you usually have undergrad students coming to the lab. You have an intervention, and then you measure the outcome immediately. And then it's actually in the lab, so it's kind of artificial. You're taking part in an experiment. And so the upside of doing a field experiment to study the enforcement of behavioral norms is that, first of all, I'm able to target a important population that otherwise it would be difficult to define. So most people do not engage in that much political incivility online, but the ones that do often do it a lot. And so this is a very specific population that I was able to identify that's theoretically relevant. I'm able to measure the outcome over the course of a continuous and unbounded time frame. So we'll see results up to a month later, which is very difficult, very expensive to do in the case of a lab experiment. And this is the point about ecological validity, that the results here are taking place. The experiment is the same context as the relevant political behavior. So from the outside, it wasn't that obvious that my bot was a bot. And so it seemed like people were engaging in the normal practice of online conversation. Okay, so this was following up on a previous experiment, which I don't know, I will skip over this because I'm taking too much time here, but this is a previous experiment to reduce racist harassment where it's the same design, but in this case, I randomized whether or not it was a white or a black bot telling people not to engage in racist harassment. And I found that, as you might expect, tweets from a white bot on a population of white users had a larger effect. So I was able to show that if you get a message from your in-group, that has a larger effect on people's behavior than a message from a member of your out-group. Okay, so how did I identify the sample of interest? One of the key problems when it comes to time is that you need to identify the behavior of interest, and then you need to intervene quickly afterwards. So I don't think I could get a representative sample of every single person engaging in online political incivility. So this is a limitation of the current design, but I think this is an important sample. I was focused on people who were real non-elite users, so they did not have a blue check. They were being uncivil to an out partisan, and they were talking about politics. So this is a perfect example here where these appear to be real people. They're being uncivil to other people, and they're talking about politics. Right? So I developed a flowchart using the Twitter API where I guess it's a little bit too large. Sorry about that. But we start by finding 100 tweets, searching with Twitter API for tweets that mention at real Donald Trump or at Hillary Clinton. And so I'm going down this flowchart to identify the behavior of interest. Is the tweet at someone besides Trump or Clinton? Are they directly targeting someone besides Trump or Clinton? If not, they're excluded. If yes, then this is the kind of non-elite behavior of interest. I'm going to calculate the aggression score and only include the most aggressive tweets. I'll talk about that in a second. Then I do a manual inspection. Does the potential subject appear to be an adult speaking English with a Twitter account at least 2 months old? This is a way to try to get rid of bots. And there's a couple other steps that are cut off here. But in general, I'm trying to find behavior that is like this, what appears to be real people talking to another real person from the opposite political party about politics. And this is how I designed the bots. So we see here a Hillary supporter bot where we have the Hillary logo in the bottom right. Hillary 2016 in the bio. The bot is over a year old, so I spent some time in advance developing the bots. They seem to have a real profile, so I have them retweet lots of different existing tweets, and I purchased them 1,000 followers. It's kind of funny, but in 2016, it was really very cheap to buy 1,000 followers on Twitter. Maybe it still is, but I think it has gotten harder, or at least more expensive. I think I spent $100 total on the followers for the different bots. And then we see a Republican bot, which is different on every dimension. It's got the Republican logo here. It says Republicans 2016. But the point here is to make it seem as though the treatment is being from a real bot. And so again, we see the intervention, Matthew, my bots, responding to Sean, applying the care treatment. So in terms of measuring the outcomes, this is one of the other key components. At this point, there was this became the Google Perspectives API. It's an open source, there's at least an API you can use to feed text in to get a measure of the aggressiveness or the toxicity of a comment. And the advantage here is that I did not develop the measure myself. One of the problems if I'm the one developing the measure, I could have done it after the experiment and I could have picked a measure which was showed the results I wanted to see. So the nice thing here is that the measure already existed. And to make it easier to analyze the data, I classified a tweet as uncivil if it was above the 75th percentile of aggression. Okay, so how do we evaluate the results? What I'm doing here is plotting the results of a regression, which is transformed into a ratio. So this is relative to the control group. What percentage change in the level of incivility did we see from the treated group? And we see that there is a significant difference. So there's a difference in the first day after treatment. And when we plot the coefficients, the difference is statistically significant. The significant difference persists into the first week after treatment. And then we see over time the effect decays. So as we would expect, one treatment does not have a permanent change in people's behaviors. Ultimately, they're going to revert back to the baseline. But the nice thing about this measurement of the outcome variable in a continuous fashion is that we can measure the rate of the decay. Okay, so we had some more specific hypotheses. So the black bar here is the public treatment, which we can think of as a placebo treatment. We see that none of those effects are significant, but actually the moral partisan treatments did have a significant effect. And the difference between these is almost statistically significant. And then finally, we see that overall, it was the care treatment that had the largest effect. So the authority treatments also did not cause a different effect. It was the care treatment that was driving the overall results. We also had some significantly different results based on the anonymity of the subjects. So I coded the anonymity by looking at their profile pictures to see if they included some real information about themselves. And so we actually see that the people with real profile pictures that seem to be real people, they really changed their behavior a lot in response to the authority and the care conditions. Whereas for the anonymous subjects, they didn't change their behavior at all. And actually, to some extent, it made them more uncivil. So we could see here the possibility of a reactance effect where it was the people who were anonymous actually were just here to mess with people. And when they got a response from my bot, they said, great, I like to mess with people, so I'm going to do it some more. Okay, so that was the experiment. And then, I mentioned the replication crisis already, and we're coming to appreciate the value of replicating experiments because just because we did something once doesn't mean it persists. So there's a problem with replication for my experiments. They can't be replicated. But not in the sense that replication crisis people mean, which means that they did the same thing and they got a different result. In this case, what I mean is that it's literally impossible to replicate the experiment. Other people, I talked to other grad students who tried to use the same method, and Twitter has changed since October of 2026 when I conducted the experiment. They've increased their ability to detect bots. They made it harder to create lots of different accounts. At the time, it was trivial. I just needed email addresses, and then I needed some phone numbers I spoofed. But when people in 2017, 2018 tried to replicate the experiments, their bots got shut down by Twitter very quickly. So it's actually not possible to run the exact same experiment. So I think this is what really got me thinking about what is the point of running these experiments if we can't replicate them. And I think that one of the downsides of studying social media in general is that it's lower in temporal validity. As I've mentioned, this is a bigger problem for social media studies than any other kind of research. Okay, so that's the first experiment. What I'm going to do now is post the same formula that we saw before. I'm going to take a break, have a little bit of coffee, and get my voice back. When we come back, I want you to have thought about how to apply this formula to thinking about experimental design. So in the case of the Twitter bot experiment we just saw, what are some of the answers to these questions? And yeah, how do we think about this experiment from the perspective of this formula that we'll be working with today? So I will take a break here, and I will come back in 9 minutes at 3:15. So looking forward to that. All right. Um, so let's get back to it. I hope you had a chance to think about these questions. So I will just, I think for the interest of time, it's kind of difficult to chat with everybody about all of these different questions, but so just some answers that I think are good for these questions are what's the theory? So we talked about the importance of incivility for driving political polarization. Um, where do we have some power in the world? In this case, it's power that comes from just being able to log into Twitter to post things and then to use the Twitter API to analyze the results. So I didn't have to really ask anybody's permission for this. I didn't need to get any funding. So I just had the power myself to run this experiment. How does the treatment relate to the theory? So this was the different types of interventions, the different messages. And I was reading the theory about moral foundations, and I wrote the messages with respect to the theory of interest. I will say, this is I'm happy to criticize my own work here, and certainly I think I've learned some things since I ran these experiments. One way that this experiment could have been better is if I had different versions of each treatment. So in this case, I just had one version of each treatment, which mapped onto a given theoretical outcome of interest. In fact, I don't know how the impact of the specific treatment was driving the results versus the part of the treatment that was related to the theory. And so in general, it's better to include multiple different types of treatments. What is the population of interest? So I saw one of the comments in the chat actually about this, which is, I think, quite clever, which is that it's very difficult to know what the population of interest is overall on social media. And this is a difference when it comes to public opinion surveys or democracy in general. When we're doing a public opinion survey, we care about citizens of a country because citizens vote. And so that's why we care about public opinion. So we know the population because we have the census, it tells us what the population is. But on social media, we don't know what the population is. There's not a census of social media users. And in this case, it's also specifically interested in people who are engaging in uncivil cross-partisan discussions on Twitter, and no one knows what the population there is. So that is a limitation of this experiment as well. The sample, I argue, is relevant. And I think that's one of the best ways to justify these field experiments where we don't know the population, is that the sample is good, not because it's representative, but because it's relevant. And I think in this case, it's relevant to the theory that I'm testing. What can we measure? So the outcome variable was the tweets sent by each of the subjects after the experiment. And I was able to measure that by scraping all of the tweets through the API using an R package. All of that is now very difficult because Twitter is, you have to pay to use the API. But so I got the text of the tweets, and then I was able to generate a measure which was related to the theory with this machine learning model to evaluate the aggressiveness or toxicity of the tweet. And the question of ethics. So again, some people are very skeptical of field experiments like this. It is the case that I did not get informed consent from the subjects. I think, it would have been impossible to do that. If I were to tell them that they were in an experiment, they would not, they would behave very differently. And it was logistically very difficult to get this. I also think that even recording information about the subjects in order to get their informed consent poses a bigger risk than just doing the experiments because they are mostly pseudonymous. I did not retain any of the personally identifying information, so there wasn't really any risk of privacy concerns. And finally, I think that the reason why this is ethical is because I think it is good to reduce partisan polarization. And it's good to try to improve the level of civility of online discussions. And so I think that in general, one of the most important components of thinking about the ethics of experiments is just the same as thinking about the ethics of actions. So if I were going online and randomly calling people racial slurs, that would be bad because calling people racial slurs is bad. Whereas trying to increase political civility in online discussions is good. And so I think that means that the randomly doing it is also good. There are the other elements, but I think that the first most important part from my perspective is, are you trying to do a good thing in the world? Okay, so that's the application of this to the case of the Twitter experiments. Uh, oh, good. I actually forgot I wrote these all down. So let's make sure my answers are consistent. I think these are pretty much consistent, but I just said all of these things from memory. Great. So I hope that was helpful. This was the first case study we're going to talk about. And I guess, are there some questions about this, or should I persist into the next? Let's see if there are any questions. Take 30 seconds.
So Kevin, we had several questions actually built
Okay.
up so far. Yes, so um, the presentation will be shared, right? Afterwards.
Yes. All of the slides, and it's recorded. Yes.
Okay, that's great. In which category of experimental design do conjoint experiments fall? That
Um,
was
so, um, yeah, we will talk about a conjoint experiment, and so this is a survey experiment, and we'll talk about a case of a conjoint experiment using a social media platform.
okay. Can you share examples of power calculators available online?
Sure. I will look at that at the next break.
Yeah.
Yeah.
Okay. And in your experience, what's the procedure or algorithm of how to deal account for confounders?
Hmm.
Yeah.
Much like,
Procedure or algorithm of how to deal account for confounders?
well, so I think that the right, like the way that we're talking about dealing with confounders is to do randomization, which
Mhm.
is I'm very confident that that will deal with confounders. There are other approaches. I am very skeptical of observational causal inference. Um, so that's why I think we should do experiments.
Okay. And there was another, well, last question at the moment. Is field experiment in real online world better than social simulation on computer regard social media?
So I think that there are, I think that one of the main takeaways here is that there's different types of validity. There are different ways to evaluate the value of research designs, and there's not a better or worse. There's a trade-off, right? So one of the things that we could get with a simulation is that we can maybe vary lots of things about the social system under study. But the downside is that we have lower ecological validity, that we have to model the behavior of the units, and that is, we're making very strong assumptions. Whereas if we're doing a field experiment, we're actually intervening with real people, and so we don't have to make those kind of assumptions. So I don't think there's a better or worse. I think there's a trade-off in terms of, what exactly we're trying to learn and what type of validity we are prioritizing.
Right. Thank you so much, Kevin.
Great. Okay, so let's turn to the next slideshow. Very good. Okay. So yes, we'll turn now to talking about, instead of online field experiments, we're going to talk about online survey experiments. So field experiments are more common in political science and econ, whereas survey experiments are more prominent in psychology, communications, and political behavior. For many of these experiments, them being online is really just for convenience. That it's cheaper, it's easier to run experiments online, and that the fact that they're online is a drawback. But I think that there are many things about using the internet which make it more continuous with taking an online survey. And that for a lot of the phenomena that I'm interested in studying when it comes to political communication, the way people use these platforms, how they learn from these platforms, there's less of a difference between a field and a lab experiment when it's being done online. So I think that this is a hybrid case of studying digital media effects. And again, it's the crucial lesson is there's always trade-offs, and so we'll talk about the trade-offs between doing online field experiments and online survey experiments now. So briefly, to contrast it with the definition of a field experiment, we have an online survey experiment where we have a digital survey. People are using Qualtrics or some other platform for taking a survey, and we have the randomization embedded within the survey. We have the different treatment conditions. So we have a control group, and then we have different types of treatments. Oftentimes, this means including political messages. We could show them different political articles. We will look at a case today where we show them different political videos, some different TikTok videos. And one of the key advantages of a survey is that after we give them the treatment, they're still taking a survey, and we can ask them lots of different questions about their beliefs, attitudes, intentions, or emotions. So one of the key differences between a survey experiment and a lab as in a field experiment is that we can get these attitudinal or belief measures from a survey experiment, whereas from a field experiment like the Twitter bot case we just saw, we're really only going to be able to get actions. And neither of these is better or worse. In some ways, actions is better than behaviors. Sorry, behaviors is better than beliefs. In some ways, attitudes is better than actions. It always depends on what we're trying to learn. So the justification for doing an experiment in a survey, first of all, again, we get to do causal inference because of that randomization. We're able to get rid of any confounders. One of the advantages for a survey experiment is that it tends to be very comparatively cheap, and you can conduct it very quickly. One of the key questions has to do with the construction of the treatments. And so in the survey experimental context, and we'll talk about this in the case studies, you can very tightly control what the treatments are in order to map those treatments onto a theory of interest. And so there's a trade-off here in terms of the external validity versus the internal validity or the construct validity of your, I love talking about validity. There's so many different cases, and there's always going to be some kind of trade-off. And when we're designing the different treatments, that's where the trade-off really bites. And so ideally, we're going to have an online panel that is large and diverse, but it's not going to be representative. And so once again, the key question is going to be, is it the right sample? Does it allow us to test the theory that we're interested in? So just like with the field experiments, there are some basic building blocks of a survey experiment where we have treatments or different types of treatments that are going to be related to the theory of interest. We're going to be doing we also need to have a placebo or a control condition. So it makes more sense when we look at the examples here. The randomization will be at the individual respondent. So there's not much of a risk of spillovers here because individual people are taking the surveys by themselves. And then the outcome will almost always be something about a survey experiment, a survey question, measuring their beliefs or attitudes. Okay, so did I go backwards? Yes. So the key here is to mimic a realistic media exposure while maintaining experimental control. And the tension is that there's still a trade-off here, where the more tightly we control the stimuli, the less realistic the experiment might be. And so we do want to make sure we have both of these components, that the media is not too weird, that it's actually something people might really experience, while the media that they are being exposed to is theoretically related, that the difference between the difference between the different treatments is only because of the theory of interest. So how do we do this? Ideally, what we should do is pre-test all of the stimuli for the theoretical clarity and realism. What this means is that if I have a video that I think is showing a politician angry giving a speech, right? And so I'm interested in studying the effect of emotion on political persuasion. And I have one video of a politician who's angry and one of a politician who's calm. A pretest would be to say, just show a small sample of 50 people. This is what, rate these two different videos in terms of how angry the politician is in the video. And then make sure that the angry one, the one that I thought was angry, actually has a higher average angry rating than the calm one. When we're doing an online survey experiment, one of the biggest issues is attentiveness. And I think this issue is only getting more extreme when it comes to the proliferation of LLMs and AI agents, that the risk that people taking your survey are bots is getting higher and higher. So this is kind of an arms race where we're going back and forth with different types of attention checks to make sure that people are real people and that they're paying attention. And we'll talk about one more recent example of this that I think is pretty compelling. Pardon me. And it's a minor point, but if we have other outcome variables of interest, we don't want to have that drive the results. So we probably want to randomize the question order. If we don't think it matters, we just randomize it so that we're sure that's not driving the results. And just like with the field experiments, it's important to pre-register our hypotheses and our pre-analysis plan. Okay, so let's say just a very simple example here has to do with misinformation. There's been a huge amount of research using survey experiments to study misinformation. So we can think of an example treatment where we show people fake headlines. The outcome is whether people believe that it's real, how confident they are that it's real, and maybe is there some bias in the fake headline. And then we can test different correction strategies. So we show everyone the fake headline, but then we randomize whether we show some people a fact check or a platform generated label. And then we see the difference between the people that got the fake headline and the fact check or the label. So one of the big advantages, I mean, as you see, this is digital media delivered in a digital survey. So it actually is not that artificial an experience to see a headline on your computer screen and then to see a fact check or a label. And this is why I think that survey experiments tend to, I mean, in general, they're kind of artificial, but they're uniquely realistic when we're studying digital media because the context of the online survey experiment is itself online. So it's not that different from if you were looking at, Facebook, you would also be seeing fake headlines and then maybe some fact checks. So the context is not as different as it is for some other cases. Let's get to let's skip ahead a little bit here. So again, the value of online survey experiments is similar to offline survey experiment or field experiments is that we have internal validity due to randomization. These experiments are likely to be very replicable. So if we do a pilot study, we can then run a much larger study. And then if I download the entire experimental protocol, I could send that to somebody else and they could actually replicate the experiment in a way that's probably not possible in the Twitter bot case we just talked about. There's a number of different online platforms for recruiting subjects. MTurk, Prolific, Lucid, Qualtrics all offer ways to find online survey participants. But there are issues with each of them, and we have to be very careful when we're thinking about which online, whether or not our sample is relevant to the intervention of interest. And then again, the upside is that we have tight control over experimental design, so we can actually test mechanisms of interest. So limitations relative to the field experiments, they know they're taking a survey. They might know that they're taking place in a survey experiment. We usually are going to be asking them for informed consent before we take the survey. Always, we are actually going to be doing that. But we are usually not going to be deceiving people. So in the conjoint experiment I'll show you in a second, we're giving them hypothetical politicians, so they know they're not real, and that might change their behavior. This might be driven also by social desirability bias. So people know that they're taking part in a survey run by academics, and they might have some idea about what academics care about. And so they might be giving responses that they think are the responses that we want to hear. And finally, we talked a little bit about the trade-off between field experiments. We can measure behavior, and sometimes it's better, sometimes it's worse, but it's very hard to measure behavior in a survey experiment, that we have to rely on self-reports or attitudes and beliefs. Okay, so applying our formula to survey experiments, the theory is going to depend on the case. So that's going to vary. Where do we have power in the world? Well, we're paying people to take the survey. So that's how the power in the world comes from, is the reason why we have people's attention is because we're paying them for their attention. And that's an upside. We're not paying them very much, so it's not that expensive, but it's also not free. And, it costs usually on the order of, 2,000 to 4,000 euros, something like this, depending on the size and the quality of the sample, which is, quite a bit of money, especially for grad students. How does the treatment relate to the theory? So here we can really, spend a lot of time to be quite careful about this and, pre-test our stimuli, make sure that there's a tight control of the stimulus with relation to the theory. The population of interest and the sample. Oftentimes here, the population is going to be the citizens, but it could be the social media users. The sample is going to be an online convenience sample, and that's a downside. How big a downside depends on the type of question we're trying to ask. And we can also, in general, pay more money for higher quality samples. So that's just part of the trade-off of basically how many resources do you have. So what can we measure? Again, it's attitudes, not actions. There's positives and negatives here. And then how does it relate to theory? That's also something that we can construct because we have a lot of experimental control in these settings. Finally, is it ethical? So in this case, I think we're really on very safe territory. As long as we're giving people informed consent, they know they're taking a survey, we're paying them enough money that is worth their time. I think that the ethical considerations here are pretty straightforward. It's not really a problem. Okay, so one key issue is that the online setting, although there are benefits in terms of the realism of studying online media in an online setting, there are also potential downsides. So there are some papers demonstrating that a given finding generalizes to a population of interest, that if we run a certain kind of survey experiment on a mechanical Turk survey sample, we can actually generalize that result to a sample run on a representative sample. We can generalize that result to a replication on a representative sample of a population. But there is what I call the paradox of generalizability. We have these findings of certain generalizabilities, but no empirical finding of generalizability is itself generalizable. That is, we found one type of thing that generalizes, but we don't know if that generalizes to all types of things. And so empirically, we're never going to be able to prove that something is generalizable. So what we have to do is, once again, make the argument that our sample is relevant for the methods and theory that we're using. So I'm going to briefly walk us through a case study of this. So this is not an experiment, but this is a way to think about the relationship between the samples that we're using in an online survey and the different studies that we're conducting. Okay. All right, so this was a study I conducted with Andy Guest from Princeton about digital literacy and online political behavior. So I think this is pretty key for essentially all online survey experiments that have to do with online studying digital media in some way. So just a little bit of background on the context here. There's a very famous case where Zuckerberg testifies before the US Senate, and the senators really have no idea what he's talking about. One of them says, well, aren't you worried that Facebook isn't going to make any money? And this is where Zuckerberg utters the famous quote, "Senator, we run ads," to the poor senator who was concerned about Facebook giving away their content for free and not making any money. And so the Senate committee that was about regulating tech that Zuckerberg was testifying before had a median age of 80. And I think this speaks to a general problem of generation gaps in digital savvy. And I mean, this really ties us back to the bond study we talked about already. I showed you the results on average, but we see that the results are much, much larger for older people compared to younger people. And then the study that really kicked off the research on digital literacy was the problem of misinformation in 2016. So people really started talking about fake news after the 2016 US presidential election. And there's a lot of research on the topic, but one of the main findings was fake news consumption was very small overall, but it was extremely highly concentrated among older internet users. So the idea of digital literacy is simply, what is it and why is it so important for understanding how people engage with online media? And given that one of the main tools that people have been using for studying misinformation research online has been survey experiments, it's really important that we understand the relationship between the samples in our surveys and their ability to understand digital media stimuli, which I think is done through digital literacy. So we define digital literacy as online information discernment combined with the basic digital skills necessary to attain it. The ability to discern whether something is high quality or low quality information, and then the actual ability to navigate online spaces to check if something is real or not. So it combines things like technological fluency, media literacy, online skills, and a general awareness of threats and privacy concerns. Okay, I will skip ahead a little bit about this to how we measured it. So the survey instrument that we designed had 3 different ways to measure digital literacy. The first one was simply the internet skills scale. So how familiar are you with the different tech terms like app, hashtag, phishing, and spyware? Another scale was the power user scale, which asked people self-reportedly whether or not they feel comfortable using online technology. And we developed a third scale, which was designed for the fact that there really are a lot of people online with very low internet skills. And it was kind of the opposite of the power user scale. The outcome of interest here is real world validated behavior. And this really illustrates the hybrid nature of an online survey experiment. So one of the concerns when political scientists are trying to study political knowledge, so we ask people in a political knowledge question, we ask them, you know, who is the Chief Justice of the US Supreme Court, or who is the Prime Minister of India? And if they know the answer, they tell us the answer, that's great. And then we know that they have high knowledge. But in an online setting, we're concerned that people might be cheating and they might be looking up the answer. And that really would decrease the value of our knowledge scores, measurements. So what we're doing is taking advantage of that and using the online setting as a context in which people should be able to look up information. So we asked them these 3 questions of varying levels of difficulty. And we said, you should use the internet right now, you know, open a new tab on your browser and look up the answer to this question. And this is a way in which we have a behavioral validation of their digital literacy. So we looked at 5 different samples in order to understand the different levels of digital literacy and the relationship between digital literacy and these different measures that we've developed. And it's very rare to compare 5 different online convenience samples here. And I think that really illustrates the importance of thinking carefully about your sample. So we used Mechanical Turk, which is a convenience sample. We recruited 500 people using Facebook ads. And we thought this would be a very broad population of people that clicked on our Facebook ad. Very uniquely, we had a high skill targeted sample. This is people that work at tech companies. So these are people we think should be the highest level of digital literacy. And then we had a small but very targeted low skill population, people who were taking rudimentary computer skills class at the Princeton Public Library. So these tended to be quite older folks who were just trying to learn about how the computers worked. And then finally, our largest sample is from Lucid, and this was quota matched to make sure that we had enough people from all of the main demographics in terms of gender, age, and race. Okay, so let's get ahead to the main results here. We see that, the different questions have different levels of performance on the different samples. So that in general, the high digital literacy sample, these are people working at tech companies, were able to get essentially all of the questions correct. But that people in the mTurk sample, Facebook sample, and the low-end sample were less good at finding these results. So that's some face validity to the idea of the problem. But the real issue here has to do with the distribution of digital literacy on these different online samples. So for Mechanical Turk, we see the whole population at the far right end of the spectrum. And it's really only in our targeted low digital literacy sample in red that we see people who are at the bottom of this measure. This is even more dramatic when we look at age. So in green here is the US population. And we see that the Lucid sample, which was supposed to be quota matched, actually does quite a good job of matching the overall population of the US. That the Facebook sample had even more older people than the Lucid sample. But the real outliers here are the tech workers in red, where almost all of them are in their 20s and 30s, and Mechanical Turk. So Mechanical Turk workers are dramatically skewed towards younger people. And there's almost nobody on Mechanical Turk who's over 60 years old. And that's a key problem because many of the studies at this time were using Mechanical Turk to study digital media effects. And if in fact digital media effects are moderated by age, there's not anybody in these samples who are at the low end of the digital literacy population. So let's see how this actually plays out. The relationship in these different plots is between age and digital literacy. So we see that on the Facebook sample, as you'd expect, older people have lower levels of digital literacy. This is also true on the Lucid sample. But on Mechanical Turk, there's actually very little relationship. If anything, older people on Mechanical Turk tend to have slightly higher levels of digital literacy. And this is evidence that this is not a very good sample to use for studying behaviors related to digital literacy. The true validation of this problem is the outcome here is information retrieval, the ability to look up the answer to those questions. And we see that as we expect, older people on Facebook are less able to find the answer to those questions, but that we have the opposite relationship on mTurk, that older people on mTurk are better at finding the information. And so this is a key demonstration that if we were to be using mTurk as a sample for studying behaviors, digital behaviors that are moderated by digital literacy, we would be finding the opposite result than the true result on a more appropriate sample. Okay, so to kind of formalize this, we have a collider. And so you might have encountered this in some statistics problem where what we are doing when we are looking at an mTurk sample for studying digital literacy is conditioning on a collider. So there is, in fact, a true relationship between age and information retrieval, and between digital literacy and information retrieval. But when we condition on looking at subjects who are in the mTurk sample, we are breaking this relationship. And so even if we were to have had a randomized experiment, we would be getting the wrong results if we were conditioning on the fact that they were all on the mTurk sample. So in general, our recommendation is do not use mTurk to study digital media effects. And although none of these online samples is representative, some of them are more appropriate given the theoretically relevant dimension. So there's not a universal measurement for digital literacy, and there's also not an ideal, best survey population. What is key is that we make theoretically informed sampling decisions, that when we decide on our sample, we're picking the sample that is appropriate given our theory of interest. Okay, so I will, I think this is important, and I will talk about 2 actual survey experiments and use our formula. There we go. Okay. Right. Okay. So we'll now walk through 2 examples of survey experiments. So just keep in mind that the main advantage of survey experiments is increased experimental control. There's no free lunch. There's always a trade-off between external validity and generalizability. And so we'll look at these 2 case studies, experimentally measuring how political communication affects 2 different things. I didn't finish this. But so the idea is to keep the experimental formula in mind. And then after each example, we'll take a second to think about how we would answer the question of, how do we fill in the formula given what we've just seen. Okay. I think we will look at the visual conjoint relatively quickly, and then we'll take another break. Okay. So the visual conjoint experiment is I've developed this with my colleague Alessandro Vecchiato, who works at Meta. This is a way to increase the ecological validity of conjoint experiments, which is a specific kind of survey experiment that someone asked about earlier. Let's just get into it. One of the biggest issues, conjoint experiments are a very popular method where we're randomizing every element of a survey experiment. It allows us to much more efficiently estimate the relationship between different components of our treatment and the outcome variable. But one of the key questions is, what exactly are we learning from the conjoint experiment? And one of the limitations of conjoint experiments is external validity. So we're going to argue that I'll show you what a standard conjoint looks like in a second, and why we think that visual conjoints, in this case, we're using a Twitter profile, is going to be higher in external validity with respect to the context of citizens evaluating politicians on social media. So once again, we're not going to argue there's a single best way to design online survey experiments, but that we think that it's important to study the context of citizens evaluating politicians on social media, and that an online visual conjoint experiment is a good way to do this. And so there are 2 different ways in which the presentation of the stimulus in a survey experiment might affect the AMCE, which is the average treatment effect in a conjoint experiment calculated for each of the components of the conjoint. The first has to do with the salience of each of the attributes and whether or not this is realistic. And second, whether or not it's actually possible in a given treatment modality to encode a given attribute. So this is an example of a standard box candidate choice conjoint experiment. All right, so in one of these experiments, each subject is asked to make a number of decisions. where they're given two hypothetical candidates for an office, and they're asked which one would you rather vote for. So we see here very clean design. We have the religion, profession, age, income, race, gender, military service, college education, and then each box contains pieces of information. What makes this a conjoint is that each of these features is allowed to vary randomly. So we are presenting people with, thousands of different hypothetical politicians. Each person is making 5 to 10 choices between these different politicians. And then we're able to statistically represent the average effect of each of these different attributes on overall vote choice. So in our design, what we're doing is rather than having all of this information conveyed in a box like this, what we are doing is conveying it in a Twitter profile, right? So we see the same information here. We have the race and gender of the person conveyed by the profile picture. We have the information in the bio saying their age, if they graduated college or their education level, if they served in the military, and their occupation. We also have some features which would not really have been possible to convey in the standard box conjoint. So one of the key components of social media in much of my theoretical work is audience feedback. So when we are looking at a tweet or a profile, this quantified feedback, the number of followers, the number of likes and retweets on these tweets, is crucial information for evaluating the quality of the person or the account. And it really it's much easier to convey this in a format that looks like a Twitter profile. It's not really possible to convey this in the box conjoint. And so we see here another example where instead of a Democrat, we have a Republican, and we have the same kind of information here. We've got age, religion, college education, and occupation. One key element of this design is that pictures of people actually contain a lot of information. And so there's a trade-off in terms of this experimental control where maybe the thing that matters the most to people is attractiveness, and they just want to vote for attractive politicians. And although we're picking the pictures because this means white woman and this means black man, they also contain some information about attractiveness and professionalness and any other dimension on which we could evaluate people. So what we've chosen to do is use pictures of real members of Congress. So we know that these are actually how Congress people look. We picked very not famous members of Congress, and we used their professional photos. So maybe they have varied a little bit in terms of attractiveness. We did pre-test the pictures. So we did the pre-test evaluation, and we had a small sample of people rate the different pictures on attractiveness, and we tried to balance the difference white woman versus black man in terms of attractiveness. But there still are some differences. But we think that using real members of Congress pictures has the highest level of ecological validity. So there are, as I said, two different reasons why we think that the Twitter profile conjoint experiment is better for this case. One of them is differential attribute salience. So when would a citizen encounter information where candidate income and candidate race have equal salience, right? It doesn't make any sense. Race is extremely important for how people think about their politicians. Candidate income, very rarely do we have that information presented to us, except in a box conjoint. And so it's actually really odd to have each of these different attributes given the same amount of space in the box conjoint. It's much more natural that the salience of the attributes varies, and that certain things like race and gender are more salient when we're using a picture like this. So again, there's not a single best ranking of attribute salience, but given our context of how citizens evaluate prospective politicians on social media, we think that a stimulus design that looks like social media is better than the box conjoint. The second is the possibility of encoding a given attribute. So the income thing is a little bit odd. It would be really weird if you looked at a politician's Twitter account and they say, I make $300,000 a year. That would be really odd. And so it's only the box conjoint's artificialness that makes that seem natural at all. And then the opposite here is that the visual conjoint allows us to see social feedback. So we can see that it's normal to have different levels of followers and likes and retweets, and also that people who are looking at politicians online or anybody online, they're going to look at how popular they are when they're evaluating them. We talked about the appearance as important already. So here what we did was we had a very high quality sample. So in this case, we decided it was important to actually pay for a representative sample of Twitter and Facebook users with YouGov. So this cost about, I think, $20 a respondent. So this cost $10,000 overall, which is really most of the Lucid or MTurk cost $1 or $2 a respondent. So this is really much more expensive. But we meant that we had an extremely attentive pop sample, and that the sample was of Twitter and Facebook users. And because the sample of interest here is citizens evaluating politicians online, it was really important that we had the right relevant sample here. So just like with the standard conjoint experiments, we had people evaluate 2 different images or profiles. They did this 10 times where they picked which one they thought was better. And so we end up with 10,000 observations here. And so we had attention checks like you should all of the time when you're doing an online experiment. We had 97% pass the attention check, which is incredibly high. So for a Lucid sample or MTurk sample, this number is close to 60 or 70%. And that just speaks to the fact that this was a higher quality sample. So the hypotheses here, we pre-registered this, again, that's very important. First, that the more salient attributes, so in the visual conjoint, race and gender were more salient, would have a larger AMCE, they would have a larger statistical impact. And that the less salient attributes, education, profession, age, whether they were a veteran or their religion, would have a smaller AMCE in the visual conjoint. We also pre-registered one specific heterogeneous treatment effect, which was that there would be heterogeneity in the respondent age and digital literacy. We just talked about the importance of those 2 variables in the visual, but not in the box conjoint. So what we thought was that people who were younger and people who were higher in digital literacy would be able to look at these profiles and evaluate them in terms of the social feedback, the number of likes and retweets, and that younger people would be more in favor of people with more likes and retweets. So looking at the results here, we can see that there are significant differences between, so we have in red, the visual conjoint, in blue, the standard conjoint. And the way to read this or any conjoint experiment is that we're going to define one of the values of each attribute as the reference. And so we're calculating here the difference between the male and female candidates. And we see, as expected, that there is a bigger impact of gender in the image conjoint than in the standard conjoint. So that's what we pre-registered. One very interesting result is that we find the opposite for race, that there's a significant penalty for white politicians in the standard conjoint, but not in the image conjoint. And this is probably due to social desirability bias. When we are asking people to evaluate politicians based on race, certain people, liberals in particular, think that they should have a preference for non-white candidates. And if we're talking about race explicitly, that becomes more salient. When we represent the race of the candidates with an image, that becomes less salient, and we see that actually there's not any overall preference for or against white candidates in the image conjoint. On average, and there's a lot of other coefficients here, but indeed that the effect is smaller for many of the other coefficients in the standard conjoint as we expect. I do want to get to the role of feedback here. So this is dividing the sample by age. This is a ridiculous number of coefficients. We only care about these. So we see that exactly as predicted in the visual conjoint, younger people have a preference for more popular politicians, and they have there's a penalty for politicians with fewer likes and retweets, but there is absolutely no effect among older people. So it's only among young people in the visual conjoint condition that we see the role of social feedback, which is what makes sense because that is where social feedback is naturally communicated in the visual conjoint, and younger people are the population that would be most likely to be affected by it. Okay, so wrapping this up, this is an example of a way in which we're really combining the standard survey experiment methodology with social media, right? So we are transforming a boring and perhaps less valid form of communicating information in a survey experiment into this visual conjoint experiment where all of the information is being communicated like a Twitter profile. So this is just one case. I think there's a lot of other interesting experiments that could be run where we are looking at using social media to encode information and learn how people learn from politicians or political advertisements or political activism campaigns. And I think that this is a kind of exciting new area to be running social media type survey experiments. But there's always trade-offs in terms of the design. And we'll see this, I think, by contrasting this with the experiment on TikTok media effects that we will talk about when we come back from this break. So again, I would like you to think about the formula that we've discussed applied to the visual conjoint experiment we've just talked about. And we'll take now a 15-minute break. We'll come back at 4:20, and then we will discuss the results to this formula for this application. So see you in a bit. Okay, let's get back to it. So let's just look at the formula for the visual conjoint experiment and see if there are any other questions. So hopefully you had a chance to think about this. So walk through the answers real quick. What is the theory? In general, people pay more attention based on how information is conveyed. So the attention varies according to if it's visual or in the box conjoint. Again, it's a survey experiment, so we have power in the world because we're paying people to take a survey. We are able to tightly control the experimental design. So the visual conjoint looks like the Twitter bot that's not the bot profile, but the politician Twitter profile, which is the context of interest. What is the population of interest? It is, in this case, the population is citizens who encounter political information on social media. And here, again, we went out of our way to really make sure we had a high quality sample. So this is a quota sample from YouGov. It's about as good as we can get in terms of having a representative sample of this population. The measure here is people's choices about which politician they wanted to vote for. And so this is them reasoning through their political choices in response to explicit information. And again, is it ethical? I think there's really no issues here. We're paying people enough, and these are hypothetical politicians. So there's no risk of any kind of deception or misinformation or anything. So yeah, that is how I would justify the research design of the visual conjoint experiment. Are there any questions at this point? Aaliyah, should I look at the questions or are you going to read them? Okay, I will look at the questions. Okay. Okay, I'm not sure which of these are about. Okay, so, all right. Okay, yeah. So sample size would be appropriate to detect the effect. So for this actually is a perfect answer to the first question, which is about the power analysis. The way that we would know what the appropriate sample size would be to conduct a power analysis. And the only way to know the answer is how large an effect do you think is meaningful? So if you're only interested in large effects, that's fine if you have a small sample. But if you want to be able to detect, let's say the outcome is favorability for a politician, and it goes from 0 to 100, and you want to be able to detect 5 on a 0 to 100 scale, that's going to be I would say, just ballpark, 2,000 people. And that's with, let's say, a binary treatment. That's all very ballpark, but in order to do a more formal power calculation, to the first person's question, I would recommend using the R package called Declare Design. Declare Design allows you to specify a number of different features of the experiments and to come up with some really nice power analysis calculation graphs. So I would recommend looking into that platform, that R package. Randomization of the question order. So you can't do this for all of the questions. Some of them have to go in order, but most of them, they're just answering questions that appear to them. They don't know what the real answer might be, so they could just answer the question as it comes to them. So it doesn't actually confuse people. Well, I think that having an experiment makes it authentic and ecologically valid. I think that it's yeah, I mean, I think that it either is an experiment or it is not an experiment. So I'm not really sure what the framing would mean, but if you're randomizing something, it's an experiment. And if you're not randomizing something, it's not an experiment. And I'm not sure how much wiggle room there is in terms of framing it. But I would say that experiments tend to be very high in ecological validity. That's the advantage here. So here, there is a trade-off here in terms of whether or not we want to do informed consent for field experiments. Um, I think that, as I said, if the ethical responsibility here is to do good things in the world, and if you're doing good things, then you're doing something ethical. Again, making sure that you're keeping track of protecting participants from harm and protecting their privacy. I think in general, we should be doing good things. So I think that the value of the knowledge we generate is worth running these experiments. Yes, for the conjoint experiments, sometimes we can answer, you just ask people to evaluate how much they like each of the two politicians. You could do that. In some methods papers, it has shown that the choosing between two different politicians yields more precise results. I think that's why we go in that direction. But that's why. And then T-validity, I didn't want to get too bogged down on this, but T-validity is just a component of the of external validity. Sorry, of external validity. So that's great. And now we can go ahead. So great. We're now going to talk about a second survey experiment, which is about TikTok edits. So this is an experiment I just conducted this year that is of a phenomenon that I think is quite interesting. It's co-authored with Valerie Lee, who's a Penn State grad student. Okay, so this is an example of an experiment for studying social media, which is near and dear to my heart in terms of what types of questions we should be asking. So this is in contrast to the emphasis on theory. Here, we're simply trying to ask the question, because digital media is so vast and dynamic that new things are happening all the time, what we're trying to do is ask the question of what is the new thing? Like what is happening on TikTok now? Like how is this theoretically interesting? And then figure out what does it do? So rather than putting the theory first, in this approach, what we're trying to do is put the actual phenomenon of interest first, and then figure out how it might be politically relevant. So we have some new thing emerging in the world of digital media. What is it? What does it do? And how does that affect politics? Another component of this that I think is interesting is the way in which rather than looking to the academic literature or famous old theorists, that people on social media are actually making sense of their own world. So I heard about the phenomenon of TikTok edits, which is what this paper is about, from a YouTube video in a private Discord by the journalist, content creator, and theorist Jules Turpak. So Jules Turpak made a video about the phenomenon of TikTok edits. She describes how they are an evolution of fan edits from celebrity fandoms to politics. So the phenomenon here, if you have not seen, I have no idea basically who y'all are. Depending if I give this talk to grad students versus professors, they have more or less of an idea of what I'm talking about. But fan edits are something where people on Instagram or TikTok or short form video take existing videos from some figure that they are a fan of, a celebrity, and they stitch them together to make an edited video, which is full of dramatic effects, basically to make their preferred figure look cool, to present them in a positive light. And so Turpak describes the evolution of these edits from just celebrity fandoms to politics. And this was a phenomenon that I was able to identify during the 2024 US presidential election. So thinking about what these TikTok edits are, I think that they are very distinct from a lot of the discussion about misinformation on social media. that they, so if we're looking at images or text, these ways of communicating online are focused on facts. And so if we are thinking about a sentence, that says that, there was a war in this country on this day, that is true or false. And it's important to think about facticity there. And it makes sense that there was focus on misinformation. If I read a sentence that there was a war in this country and there was not, that's actually really bad. But these edits are really not about facticity. They're not designed to communicate facts or true, they're not true or false. They're trying to produce a compelling aesthetic experience. So they're obviously not depicting reality. What they are doing is presenting a synthetic point of view. They are stitching together existing videos to present a point of view on the desired figure. In this experiment, we're using TikTok videos to see if TikTok edits are able to change voter perceptions. So in the course of looking on TikTok during the presidential election, I identified two different types of edits involving politicians. The first one are thirst trap edits. So these are, part of online culture. The goal here is to make politicians appear attractive. Just like any thirst trap, the idea is that I'm a fan of this person, I want them to look attractive. So this uses lots of soft video filters. In this case, the two politicians of interest are Joe Biden and Donald Trump. So these are both fairly old men. And so in the desire to make them appear attractive, they used younger footage, used them engaging in stereotypically attractive activities, and with flirtatious or charming expressions. The second type of TikTok edit that I identified was called a badass edit. The goal here is to make politicians look intimidating or powerful. They used a lot of dark video filters, dramatic audio tracks, some kind of formal settings, wearing a tie, having a lot of power, usually involving some kind of patriotic or military imagery, saluting, getting off the helicopter, Air Force One, this kind of thing. These are the two types of edits that emerged as I was looking at this type of film. These are example screenshots of the edits. So this is the Joe Biden badass edit where we have him giving a very intense speech, looking angry. And then here we have the thirst trap edit where he's looking charming, his hair is still brown. And so he's looking more attractive here. And then we have the two different Trump videos where we have the kind of grainy, intense video of him looking badass on the left, and then him a bit younger and with an attractive younger woman on the right. And so these are just examples of the stimuli that I showed them in the experiment. The research design here, we had 2,800 respondents recruited from Prolific. So this is definitely not a very high quality sample, but they did at least have quota sampling to match the US Census. So we have people who are of the appropriate distribution of gender, race, and age. We did an attention check here, and we excluded 500 people because of the attention checks. One thing I need to mention here is that this is a specific kind of attention check. So the standard attention checks have people just look at a basic survey question and say, ignore all the other sentences, just click the fourth option. In this case, it was very important that our subjects be able to listen to and watch video with the audio track, right? So we did an attention check where we had them listen to an audio track and then click the answer that the audio track told them to. So if they didn't have sound or they were in a place where they couldn't listen to sound, this prevented them from taking the experiment. I think that's important given the centrality of audiovisual effects to the TikTok edits. So how did we select the treatments here? And this is going to get back to one of the main themes, which is about the trade-off between different types of validity when we're doing experimental design. The way we selected the stimuli was we looked for the best edit in each category, looking in terms of the number of views that it got on TikTok. So I searched the TikTok hashtag API for Biden edit and Trump edit. At this point, it was still possible to access TikTok API. At this point, it's a little bit more complicated. You have to apply for access. But so I was just looking to find the TikToks that had the Biden edits or Trump edit hashtag. And I was looking within each of these different categories for the badass and the thirst trap video for Trump and Biden. I picked the TikTok which had the highest number of views. So this means that I was looking at the TikToks that were the best TikToks. And this is a trade-off in terms of external validity versus experimental control. So each of these 4 TikTok videos was different in a lot of different dimensions. If I had wanted to maximize experiment control, I would have done a design that looks more like the visual conjoint that we just talked about. In the visual conjoint, remember, I'm picking every single dimension. I'm constructing the stimulus in a totally artificial way. And so I control everything. And I'm very sure that the differences that I identify are because of the specific things that I put into it. In this case, I identified 4 different TikToks, but because these are, 30 to 45-second videos, there's a lot of different ways in which they are different. And so I can't be 100% confident that the effect is driven by one specific mechanism. They vary on all these dimensions. And that's just a trade-off when it comes to thinking about how we're going to do experimental design here. One of the biggest dimensions is the videos varied in length. Some of the videos were only 23 seconds, and some of them were almost actually twice as long, 52 seconds. But I think the most important dimension on which they varied, which I think I will talk about later, but just we'll mention it now, was in terms of quality. So different videos had more views. In particular, the Trump videos all had more views than the Biden videos did. Maybe this reflects the fact that the people on TikTok were just more interested in watching Trump videos, or they just weren't very interested in watching Biden videos. This was conducted in the summer of 2024, just before Biden dropped out and was replaced by Kamala Harris. So he wasn't exactly the most popular politician at this point. But overall, the Trump videos were higher quality in terms of the production value and in terms of the number of views. So that's another way in which they differed. Okay, the procedure here, we put 50% of the subjects into the control condition, 50% into treatment. For the control group, I showed them 3 non-political edits. So when you're doing a media effects experiment like this, in particular, it's very important if you just had the control view group do nothing, then you're bundling in the fact that people watched a video about anything with the specific content of the video. So here for the control group, I specified 3 non-political edits. So 2 thirst trap edits of celebrities Ana de Armas and Cristiano Ronaldo, and a badass edit from comedy films. The treatment group watched 3 politician edits. So they either watched a Biden edit, either they watched 1 Biden edit, either the thirst trap or badass. Then they watched 1 Trump edit, thirst trap or badass, and then they watched 1 RFK Jr. edit, which was kind of to distract them. So there were 2 outcome variables here, and so relevant to the purpose of these thirst trap videos and indeed of audio-visual communication in general, one of the outcomes was just how attractive people rated the different politicians. And this is in the control group, these results here. And this is to demonstrate that attractiveness actually does vary a lot across the different politicians. So we see that the average rating of attractiveness of Biden is quite a bit higher than Trump. This is clearly driven by partisan motivated reasoning. The fact that this distribution is bimodal is unnatural. And so there's clearly many people who are just, rating Trump as very unattractive and Biden as somewhat neither unattractive or unattractive for partisan reasons. But we also see RFK Jr. is rated as significantly more attractive on average than either of those two or Bernie Sanders, who I included just for contrast. So we do see significant variation in this population of old white male American politicians in terms of how attractive American people find them. Okay, looking at the results here, we see the treatment effect of the different edits. All of them had a positive effect on attractiveness, but as expected, the thirst trap edits had a larger effect than the badass edits. So in the case of Biden, the thirst trap edit was actually dramatically larger, and it really had a large impact on his rating of attractiveness. For Trump, actually, both of them had roughly the same size. For favorability, we have a somewhat different result. So as expected, the badass edit had a larger effect on favorability, and this is measured in terms of the 0 to 100 scale, or the feeling thermometer scale, which is common in ratings of politician favorability. So we see a pretty significant increase for Trump and a larger increase on the badass edits, but neither Biden edit had any effect on favorability. And so I think that this could be driven by, as I was mentioning, the fact that the Trump edits were higher quality. That there's not really a difference per se about Trump versus Biden, but just that the Trump edits were higher quality. At the same time, that might be evidence that people liked Trump more, at least on TikTok. And so the fact that they were higher quality is not totally random, but is kind of evidence of upstream effects on the production of these TikTok edits. So we pre-registered a number of different heterogeneous treatment effects. And so we tested all of those. You have to, if you pre-register something, you have to test it and you have to report the results of that test, right? We expected there to be differences in respondent partisanship, respondent age, TikTok use, and respondent gender. And we did not find any evidence of heterogeneity, which is very surprising, especially when it comes to there were no treatment effect heterogeneity for respondent gender, for attractiveness, which was striking since these are all men in the experiments. We thought the effects would be different for men and women, but they were not. And there was no evidence that partisanship moderated any of the results, which is, again, unexpected. Okay. So first of all, I think this is a very cool experiment. I think that there's a lot of things happening in TikTok and visual media on social media that we have not been studying very much. And so I think this is a nice way to start to do that. But I think when it comes to the key decision about experimental design, the trade-off here is about ecological validity versus experimental control. So in this case, again, I prioritized ecological validity by using real edits. These were actually edits that people had made, but that meant that I was not able to ensure or even really attempt to have them only vary on a single dimension. Again, it's a trade-off. Neither of these is perfect, and this means that a very natural follow-up experiment would be to take the same video and then edit it in different ways, right? So we could add dramatic audio filters, or we could add certain clips to the edit, and then we could see more carefully what's driving these results. I will say that I think that this is a lower bound on the effect. I think that there's evidence that women and people of color face greater scrutiny regarding their appearance when they're politicians and in general. And so the fact that these are all fairly old white men kind of lowers the importance of attractiveness. But so to wrap this up, we do find evidence that TikTok edits can change viewers' evaluations of the politicians. We're able to move attractiveness more than favorability. But in general, as I say, I think that this is more and more content online is becoming audiovisual, and that's kind of changing the nature of political communication. So we're moving less to think about the importance of facts and more to think about aesthetics And so physical attractiveness is going to be more and more tightly connected to favorability moving forward. So TikTok edits are evidence of this larger shift from facticity as a mode of communication to aesthetics. And in general, I'm going to argue that image manipulation is a post-rational form of persuasion. This is an example of this. You might have seen a rather prominent number of memes where Vice President J.D. Vance was edited to either look extra attractive or extra unattractive. And obviously, this is not rational. This is not a serious form of deliberative persuasion. But this is, as we move to a world where there's more and more audio-visual content and the ability for average people to edit images and videos, we're going to be seeing more of this kind of content. And I think there's a lot of space to be running experiments about this kind of communication. Great. So that is the end of this presentation. So now let's take what we've learned here and apply it to the formula that we've been using. Okay. So hopefully you're getting the hang of this and thinking about how we are thinking about research design here. So from the TikTok edits experiments, what is the theory? That affective, non-rational cues affect subjective evaluation. Where do we have power in the world? Survey experiment, pretty simple. We pay people to take the survey. How does the treatment relate to the theory? We are experimentally varying the videos. So they are going to be the badass edit or the TikTok edit. But again, note that we did not do this in terms of maximizing experimental control. We went to increase the ecological validity. So the population of interest here would be citizens who encounter political information on social media, I guess in this case, specifically on TikTok or Instagram, or all of the platforms now are increasingly audiovisual, but these are the, more. And a drawback here is that the sample is online convenience sample. What can we measure here? It's subjective evaluations of politicians. So we ask them survey questions and they are giving us their answers for the attractiveness of the politician and how favorable they are towards the politician. And then in terms of the ethics, so obviously we're showing them edited videos, but we didn't make the edited videos. And if they were to go on TikTok, you would definitely find these videos very easily. So we told them that these are real videos from TikTok. I don't think anyone, again, they're not obviously real or false. They're obviously edited videos. So I don't think there's deception. And we paid people sufficiently. So I think there's really no ethical concerns here. Okay, well, that's this second slide deck. I think we should go ahead and do one more case study, but are there any questions at this point? While I'm switching slide decks, feel free to ask any questions. Okie doke.
There's no further question at this point.
Thank you. Okay, so we went to survey experiments studying social media, and now we're going to go back to field experiments studying social media. So remember that in contrast to the survey experiments, the advantage of field experiments is the increased realism, that we're actually acting in the world, and the possibility of unexpected outcomes. And we will see a case of unexpected outcomes in the next case study. There are no free lunch, always trade-offs. Really trying to drill that point home when it comes to thinking about experimental design. And so the trade-off in this case is we get increased realism, but it makes it more difficult to connect the theory to the experimental design. We're often not able to implement the perfect treatment from our theoretical perspective. So we can only implement the treatment that we are interested in, but not the ideal one. Okay, so there are two more case studies that I will talk about here, which are experimentally manipulating real aspects of the digital field. The first one, again, sorry, we'll look at the experimental formula after each of these case studies. So the first experiment is an experiment conducted on Twitch. So I will switch to that slide deck. And so I imagine that this audience might be more familiar with Twitch than some. And this is, in many ways, an update of the original experiments about Twitter bots from the earlier in today's presentation, and updated to the novel context of Twitch. So Twitch, for those of you who are unaware, is a platform designed for streaming chat. Most of it is for discussing video games, but increasingly it's used to discuss basically everything under the sun. And I do have to thank Congresswoman Alexandria Ocasio-Cortez, who is one of the most assertive adopters of new media technology, simply to demonstrate the importance of these new media platforms for politics, because certainly some political scientists continue to be skeptical of the importance of things like Twitch, but because AOC is using streaming chat, that's evidence that it's actually relevant. So streaming chat, if you're unaware, is increasingly popular among young people. One of the questions we want to ask is, what is it and why do people use it? So one of the key things about this is that it has a high density of information. And so once again, kind of related to the post-rational persuasion we were talking about with the audio-visual, the point of chat in the streaming chat, the reason why I'm typing in messages in response to the streamer I'm interested in is because I want to express myself. I'm not trying to persuade anybody. It is like watching a soccer game. I'm not yelling at a soccer game to persuade the opposing team's fans. I'm just participating as part of a group, maybe cheering on my team, but the idea that this has anything to do with persuasion is kind of a mistake. We're increasingly seeing cases like the current lecture, where we have sort of a hybrid type of media between a podcast, a live stream, and a recorded lecture, which live streams are always posted online recorded. And the reason why I think this is important, we conducted this experiment in 2024, but as part of the post-mortem of what was important in 2024, the argument was that podcasts and streamers played a big role in presidential campaign strategy. And that this is the time where this new kind of technology is really going to take over political communication. And that in particular, this is a space that is largely dominated by men, and that it is a space where we're seeing the drivers of increased gender polarization. Okay, so just to make sure we have enough time, I'm going to skip over a little bit of the background on social media and the previous experiments, just to talk about the current experiment. So the experiment we conducted was on a set of political streamers. We found one of my co-authors, Sung-Yeon Kim, had a whole paper identifying the population of political streamers in US Twitch streams. So we had essentially all of the people who were talking regularly about US politics. We engaged in block randomization. So the block randomization, recall, is a way to make sure that the treatments are balanced. And the design of the treatments varied on two different dimensions. Whether the treatment was civil or not, and we will see how we operationalize that in a second, and the opinion congruence, whether or not we were agreeing with the streamer or disagreeing with the streamer. So just like in the Twitter bot experiments, the outcome here is going to be based on changes in the chat. So we are looking after we intervene in the chat to see how this affects the way people talk about things. But in this case, we're going to argue that the qualitative outcomes are at least as interesting. So this is an example where we're doing a field experiment, and what's cool about this is that something unexpected can happen. And when we record this, that really allows us to refine our theoretical understanding of the case. Okay. So once again, revisiting this kind of crucial question of realism versus control in stimulus design. So we talked about this question in the case of the survey experiments, but the problem persists even if we're doing a field experiment. Sorry, my voice is giving out here. So how should we define the treatment? There is, once again, a trade-off between the control / replicability of the experiment and the ecological validity. So we saw in my original Twitter bot experiments, in the first one, which was about racist harassment, I used the exact same message for every single person. Hey, man, just remember that there are real people who are hurt when you harass them with that kind of language. So, I mean, it's very easy to replicate this. You just copy and paste this exact string of words. And there's tight control. Like, we're using the exact same message. So we're very sure that the differences in this case, if there were any differences, were being driven by the identity of the bot. The downside of that treatment, it's first of all kind of awkward. It's stilted. Sometimes it might not make that much sense. And particularly in the case of streaming chat, I talked about with the Twitter bot how it had to be fast. But in the streaming chat, it has to be very fast because the chat is going by so quickly. We would have to have some kind of message which was responding to the actual content of the chat happening basically in real time. So in this case, what we defined as the treatment is the lead author, Chloe An, watching the stream, thinking about how to respond according to the dimension of treatment. So is it civil or uncivil? And are you agreeing or disagreeing? But once we've had that randomization happening, the treatment is a natural intervention according to the condition, which makes sense according to what's actually happening in the conversation. So obviously that's less easy to replicate, and there's a lot more variation in the exact nature of the treatment. But I think that here we have more ecological validity, and it's basically necessary because having an identical treatment would be too stilted. So here's an example of some actual treatments here. Here's a message which was civil and agreeing with the streamer. I appreciate your viewpoint a lot, and I agree with you on so many levels, the judge selection process, whatever. It's just whatever they're talking about. Thank you for sharing your thoughts. Very civil and agreeing. This is civil and disagreeing. I'm sorry to say, and I do appreciate your viewpoint a lot. And then is very, very kind of polite, as you see. And so in contrast, we have uncivil, and we see here, for ethical reasons, we did not want to be, that uncivil. We didn't include any curse words or slurs or personal attacks. And so what we mean here by being uncivil is to say we're using lots of caps, and in this case, a lot of exclamation marks. So that annoys me so much is the extent of the incivility here. And so specifically, how did we operationalize this? Whether or not it was uncivil a little bit or very uncivil is using capital letters and exclamation marks. And then to be civil, we say, I appreciate your viewpoint. That's how we combine experimental control about defining the treatment condition with the fact that we would have to change each treatment to respond to the stream as it was going on. Okay. So in order to do adaptive randomization here, this is a kind of more sophisticated version of block randomization. And it's necessary in this case because we did not know the actual population of interest. So we are block randomizing according to the different number of streams that fit different conditions. And because we weren't sure what this was going to be up front, we had to do the block randomization in real time with this balanced adaptive randomization. So we decided to, in order to make things more comparable, do the intervention between minute 30 and minute 60 of the stream, making sure that Chloe could actually watch the stream at that time. But there's a problem here. There's an error in the randomization procedure because of a sparse feature space. So we actually made a mistake here. That's less important. But the issue that is a problem in general, if you're trying to do an experiment like this, is that the treatment is endogenous to action in the chat. And so although we think it was good to give Chloe more discretion because of the need to have this more ecologically valid intervention, the way in which she decided, or anyone would decide, to actually intervene in the chat is that to post a comment when things were already getting more exciting. So when there was action in the chat, she became more likely to post something. And that's a problem because there's reversion to the mean. So when she posted something, on average, it was already at a high level of activity and incivility. And then after that, it naturally went back down to be less exciting. And so the fact that there was some endogeneity, some non-randomness in when we applied the treatments actually produced a confounder. And so, I mean, the issue here is it looks nice in the original experiments, where actually in the time period after we leave the civil comment in green, we see this significant reduction in the toxicity or severe toxicity. That's exactly what we were expecting. Unfortunately, this is driven by the problem of the endogeneity of the treatment design. And so if we actually adjust for that appropriately, we find no results. So this is disappointing, but we are going to run it again, and we want to share the lessons we learned for how to do this kind of experiment. So it's just very difficult to do a realistic real-time intervention. So one solution is to randomize the type of treatment. So pick the condition, and then you write down your response, and then you do another randomization for whether it's the treatment or the control. And then if it's the treatment, you put it immediately, and if it's the control, you just delete it. So that's a way in which to make these different ways of delivering the treatment identical, except for whether you actually do it. One downside of this is that it wastes a lot of time writing treatments that you're not actually going to send. One other approach, given that this is very time consuming, is to get a lot more controls and sacrifice some realism. So one of the features of real-time streaming chat is that we could construct control groups from all of the streaming chats that we don't intervene in. Right? We're barely intervening in any of the streaming chats. And so there's a lot of control groups out there. The question is, how do we define them in a way that we're not introducing some kind of bias? So we thought about describing control groups based on time. So for a given day, we could say that any stream where the intervention happens so any stream that we did not intervene in, the control group could be a stream that was happening at the same time of day. Alternatively, we could also say that any control group was constructed by any live stream that was happening at the same time of day and the same point of time in that live stream. That's the tier 3 here. The same distance between when we're defining the treatment intervention and then when we're actually doing the treatment. So we could go and define control groups throughout all of the other live streams on all of the other days, and thereby increasing the size of our control group and getting a lot more statistical power without actually having to do the work of doing these interventions. Okay, so I mentioned some interesting unexpected results. And The main one is that we were banned from 6 out of the 162 streams that we intervened in. It's not a huge percentage, but it only happens when we were disagreeing with the streamer. It didn't matter if we were being civil or uncivil. But so that's actually pretty significant to have 6 in the disagree and 0 bans when we were agreeing. And, this is not a statistical result, but it is evidence that there is some kind of, let's say, curation happening or the generation of echo chambers by the moderators of these live stream channels. And so we didn't, pre-register this. We didn't expect to find this, but it's still something interesting that happens when you intervene in the real world. And it's something that, we could design a different experiment moving forward to study. Even we could use some kind of qualitative studying methods to figure out what's going on here, like try to interview the moderators of these live streams to figure out if this is actually their motivation. Another unexpected result was the name of the intervener. So originally, Chloe used a name that had her real name in it. And in fact, this really got a lot of attention. So it's uncommon in these spaces for someone to, voluntarily identify as a woman. And so a lot of people were talking to her as if, wow, I can't believe, you're a woman talking about these issues. And so that was really surprising. So for the purposes of this experiment, we dropped the gender identification, but that actually leads to a follow-up experiment that we're hoping to conduct where we randomize the presence of gender identification in our intervention. Okay, so the results here, I don't think, they're not very meaningful. It was a pretty small experiment and there were some design flaws. But why I'm talking about it today is that I think it's informative about how to run this kind of experiment. So this is a proof of concept. As I said, we're going to do a follow-up about gender self-presentation. And the larger goal here is to collaborate with influencers to deliver a larger treatment. We'll talk about that at the end of today's presentation. So thanks. That's this presentation. So now I will switch back one more time and let's take a minute here to think about the formula for the Twitch experiment. We'll take one final quick break, 8 minutes, and come back at 5:15 and wrap this up. Thanks. All right. Let's get back to the final session here. All right, so let's revisit this question of the formula for the Twitch experiment that we just talked about. Okay, so what's the theory here? That we're interested in understanding norms of discourse in anonymous settings. How can we improve the quality of discussion on Twitch? Where do we have power in the world? In this case, this is a free field experiment, so it's hand implemented at this point. Just like my first Twitter bot experiment, this one was conducted by a grad student, but in this case, I was not the grad student doing the conducting. So thanks again to Chloe for the hard work there. And the outcome variables, we were able to download all of the chats from Twitch. So that's how we were able to collect all of the data for free. How does the treatment relate to the theory? We are able to manipulate the nature of the treatment and to make it more or less civil and to vary whether we were agreeing with the streamer or not. Again, I think this was a limitation that these are not necessarily the ideal treatments that we would be able to apply, but there was some trade-off in the need to naturally be able to respond to the conversation. So it's kind of a, as I say, a limitation of a field experiment in this case, but the upside is the increased ecological validity. So the population, we were able to define in advance the population of political streamers. So, you know, we can't generalize beyond political streamers, and there's not that many of them. I think that there were fewer than 2,000 streaming about US politics in 2024. But with this population well defined, we have a quite strong sampling frame to have a random subsample of medium-sized streams. I didn't mention this, but we ignored the streamers that were too small or too big. So we wanted ones where there was some activity in the chat, but there wasn't so much that our intervention would go up the stream in 1 second. What do we measure? As I said, we scraped the subsequent chat in the live stream, and we analyzed it, in this case, by feeding it through the algorithm to estimate toxicity. But you know, there are many other features of the chat that we could analyze, and this is the nice thing about using text as data to generate your outcome variables, is that there's lots of different you know, ways you can operationalize the chat. And so is this ethical? You know, we did not get informed consent from every single anonymous person in the chat, but we think that our actions were good, or at least neutral, and that we did not do anything unusual. We didn't pose any privacy risks to the subjects. And so we think there's not any ethical issue here. Okay, so before we turn to the final case study, I wanted to ask if there were any other questions. Looks like there's one. Let's see. Oh, which one was this in reference to? I guess it must have been are there any studies where experiments like that are replicated offline too? So it is a question that people often have, is sort of like, what would happen if the question were offline? If the experiment were offline, if it was online versus offline? My argument is generally that people are the same online and offline, that if they engage in some behavior online, they are going to be the same person when they turn off the computer. So the effect will persist offline. And in this case, I think that the fact that it's live chat, live stream is such a naturally online phenomenon that it isn't really possible to do it offline. There are some cases where people have tried to do the same thing online and offline to trace the you know, persistence of some kind of effect. I can't remember them off the top of my head, but there are some of them. And happy to recommend some after this, if you're really interested. Okay, So the final case study we're going to talk about for the field experiments is the meta experiment, which is here. Good. So this one I was not involved in, and it is one of the most I think largest and most important set of online social media experiments. So I would be remiss to not spend some time talking about the Meta 2020 collaboration. Okay, so briefly, this is what we'll talk about here. This experiment is part of a collaboration between roughly 35 independent academics and people working at Meta. They had a number of different descriptive studies and experimental studies during the context of the US 2020 election. And this is an experiment which allows us to study algorithms. And I think, I want to talk about this because algorithms are one of the most important topics on social media. And they are also very frustratingly difficult to study experimentally. So there have been many people who try to study algorithms through some kind of audit, where, for example, on YouTube, people ask, they search YouTube videos and they create many different accounts to see what is recommended to them. But this is not actually realistic. So the reality of algorithms is that they are personalized and they are based on huge amounts of data collected about our behavior and preferences. And so it's not really possible, pardon me, to study algorithms in this kind of not like depersonalized way. And so this is an experiment which actually manipulates the algorithms at the source, which is, I think, very effective. So as I'm sure we're all aware, algorithms are central to modern social media. They are influencing what people see, what they engage with, and then ultimately, insofar as people are changing their opinions and actions based on what they see in social media, algorithms are affecting what people believe. Lots of concerns about whether algorithms increase polarization, increase exposure to misinformation, or create echo chambers. But I mean, the issue is that the algorithms that we really care about here are black boxes. We cannot really observe what is happening inside the algorithm. All we can do is measure their effects. So this experiment, again, it was part of the 2020 US presidential election set of experiments. So for a sample of Facebook and Instagram users, these people were switched from the standard algorithmic feed to a chronological feed. So the chronological feed is what old school social media platforms used. So when Facebook first had a news feed and when Twitter first came online, the tweets and the posts were just showed to people in chronological order. And only later did they start to change the order that they showed you things based on the algorithm. And that's really when a lot of people became especially concerned about the role of these algorithms in exacerbating phenomena that people were worried about. So the experiment here is affecting, seeing how this shift experimentally changes users' experience and behaviors, and then downstream how this affects their political attitudes. So the two platforms that were studied here were Facebook and Instagram. This is a massive experiment. It's not 61 million, but I don't think we'll ever see a 61 million person experiment again, not on social media anyway. But 45,000 is quite large. compared to your average social media experiment. The period of study was before, during, and after the US election. And so the design here was a randomized control trial or a field experiment with two conditions. So people either had the default algorithmic feed that everyone has, or they were treated and moved into the reverse chronological feed, where you are being shown the newest posts first. And as you scroll down, you are seeing the oldest posts. On the upside, this is a very large RCT that actually was embedded in the real world platforms. As I said, this was done in collaboration with Meta. It's not possible for an independent academic to change how a social media platform operates at such a fundamental level without this kind of collaboration. So the survey participants were invited in the app to take part in the survey and the experiment. So Facebook and Meta, Facebook and Instagram, or Meta, they know the population of users in a way that we really cannot. And they were able to do quota sampling on the dimensions of interest. Now, note that it's opt-in, so everybody who participated in the experiment knew that they were taking place in an experiment. They knew they were taking surveys. They knew they were getting paid quite a bit of money to do this. But the sample was still representative of the population as a whole on these platforms. The experiment included measurements from surveys, from behavioral tracking on the platform, and how people engaged with what they saw. So obviously there were a lot of ethical concerns here. First of all, there was informed consent, there was debriefing. There's also ethical concerns here, not about the impact on the subjects, but rather on, is Meta, the extremely wealthy corporation, going to try to affect the results to make it seem like they're not doing any harm? And so in order to prevent that, there were a number of steps taken by the collaborative team, ensuring transparency in the process by which they decided on what research questions to ask and how they actually implemented them, with some constraints on protecting user privacy. There is a trade-off here in terms of the transparency of the research with the need for individual users to maintain their privacy. All of the experiments were pre-registered, and so all of the results of the experiments were reported. And so Meta was not able to suppress results that they did not like. So I think, I'm in some ways skeptical of this kind of collaboration, but I think overall this was very well done, and I think we can trust the results of the experiment. So the hypotheses coming out of this research design, first, that based on the concern that the algorithmic feed is increasing polarization, we should think that the switch to the chronological feed will reduce issue polarization and affective polarization, two types of polarization that political scientists are concerned with. Maybe there's a trade-off, though, that we will get less polarization, but we will also be exposed to less political news overall. And so therefore people in the chronological feed will have less political knowledge than people in the algorithmic feed. And then there will be less political engagement in the chronological feed, measured in terms of both validated voting, just like in the first Bond experiment from 2012, and in terms of how much people engage with information on the platform. So first of all, there's some upstream results in terms of the behavior. the largest impact was that people spent less time on the platforms. So in general, this is evidence that people like the algorithm, that as much as people complain about the algorithm, it actually does show them things that they are more interested in. And so when you switch people to being in the chronological feed, they just stop using the platforms as much. When they did use the platforms, they were less engaged. So they liked fewer posts, they left fewer comments. Somewhat counterintuitively, the chronological feed led people to see more political content and more untrustworthy content. So in general, this means that Facebook and Instagram's algorithm is actually downweighting political content and untrustworthy content relative to the content that people are posting if you only looked at the chronological feed. And so we also see that there's less incivility on Facebook in the chronological feeds. There's some tension here where there's more untrustworthy content, but less incivility and more content from moderate sources. So, I mean, this is part of the value of doing this experiment. These outcomes are not really the downstream outcomes of interest, but they do tell us something about how the algorithm actually works in a way that we would not be able to know, without doing this kind of experiment. The top line result is that there were not really very big results. So this 45,000 person experiment, I should say that the duration of the experiment was 6 weeks. So the people in the control condition were switched for 1 week, and the people in the treatment condition were switched for 6 weeks, I believe. And so we see that it's a pretty large duration of time where we have, the ability of this treatment to continue to impact people over the course of 6 weeks. But even still, we see no significant effects on affective polarization, issue polarization. So that's, first of all, do people like, or do they dislike and distrust members of the opposite party? Or do they get farther apart in terms of their preferred level of different issues in politics? It did not change their knowledge of the election. It did not change their trust in media or in institutions, and it did not affect their self-reported turnout. It did affect their engagement with content on the platform. They were less likely to engage with political content. I mean, largely this is driven by the fact that they just didn't use the platform as much because they didn't like it. But that is one of the significant results that we see here. So why is that the case? We have the large behavioral changes where people are using the platform less, they're engaging with it less. There should be some, if the platform is changing anything, then there should be some downstream behavioral changes, but we didn't find it. And so this is one of the questions as to why. Maybe that the effects required a longer exposure, but frankly, 6 weeks is quite extensive. I think, all of the people designing this experiment and myself would have expected 6 weeks to be long enough, but maybe in fact, it's not long enough. Maybe for polarization, it's just not enough. We can't depolarize people who have already become polarized just by removing the source of the polarization. That makes some sense, and it also is a very pessimistic conclusion. And another possibility is that people were just interested in finding good algorithmically curated political content, and when Facebook and Instagram stopped giving them good algorithmically curated political content, they switched to a platform that did provide them that. And so maybe they just started using TikTok and the overall effect was the same, and they just found access to an algorithm somewhere else, which kind of defeated the role of switching the algorithm on the Meta platforms. So, I mean, in general, this is a good experiment. I mean, I think we should trust it. It's got real users, a lot of ecological validity, and the different types of outcomes, including both surveys and behavioral tracking, is quite impressive. So one of the issues, I mean, is the limited general equilibrium effects. And this is generally a problem with studying algorithms, right? So the chronological feed was broadly full of low quality content because everybody else on the platform, other than the 45,000 people in the experiment, were not part of the experiment. So the types of things that are posted are actually the same on the platform as a whole. And this is what is meant by limited general equilibrium effects. What we're seeing is, what if we change the algorithm for one small part of the ecosystem? Whereas the algorithm actually is continuing to affect both the production and curation of content on this platform. So we might, if we were to roll out the chronological feed on the course of a year for the whole platform, then we would see some very different results. And who knows what they would be, but there would be general equilibrium results. And this is, in general, even though this is pretty much the largest experiment, the largest intervention we can really hope to conduct on a live social media platform, there are still limitations for understanding the roles of algorithms in these collective environments. Another issue is that there was only one algorithmic alternative tested. So we had the standard algorithm or else the chronological feed. And maybe the chronological feed just is not a very plausible alternative. And instead, we could have tested a more curated algorithmic feed, which was specifically designed to remove political content or to I don't know, like we could imagine any number of algorithmic alternatives, and we only get to see one tested here. And of course, this is happening in the US in one specific election, and maybe if it were done somewhere else or a different time, maybe we have some different results. So, I mean, in general, I think we take away from this that algorithms are clearly powerful, but it's not obvious what their political effects will be. That this measurement strategy, the experimental design strategy are very, it's very good, very strong. And that this was a well-powered experiment, 45,000 people. It was pre-registered, and we still have no results. And I think that we should really take something away from this and not say this was a failed experiment, but in fact that we should sort of lower our estimate of the importance of the algorithm for these downstream political consequences. Okay. So that is the end of this discussion. I want to take us back one more time to the formula. Okay. So what is the formula for the meta-algorithm experiment? So what's the theory? Algorithmic feeds drive polarization and knowledge and engagement. Where do we have some power in the world? Well, we don't. There are a small number of academics who were able to collaborate with Meta, and it's an example of a very powerful strategy, but obviously not something that everyone has access to. How does the treatment relate to the theory? Well, they control the online universe. They were able to change the algorithm, but kind of connected to what I was saying in the limitations, I don't think anyone was really saying that we should care about the chronological feed. The chronological feed is an outdated format of presenting information, and that maybe it would have been more compelling if they had tested a more plausible alternative algorithm. The population of interest, in this case, this is a clear advantage here. It's all of the Facebook and Instagram users over 18 in the US. And Meta knows who these people are exactly, so they were able to generate a very high quality sample with the caveat that it would only include people who opted into the experiment. So what can we measure? In this case, we have measured two different types of things, which is quite powerful. So the on-platform behavior, what they are actually exposed to, what they decide to click on and like, and then also the survey questions about polarization. And then the larger, I mean, I think in this case, the ethical question is a bit more complicated. But in general, Meta is a corporation. Tech companies run hundreds of experiments every day that we never hear about. So I personally don't find this very objectionable. I think that it's good for tech companies to rigorously test out different features of their products and then evaluate their effects on things like partisan polarization. If anything, I wish they had done this experiments when they first switched to the algorithmic feed. I think that would have been a much more kind of compelling test if they'd been running experiments like this the whole time. And I mean, in this case, the subjects opted in and were well paid, so I don't think there's that much of a concern. And if anything, it's the larger problem of Meta collecting all the data around the people. That's the problem, not the experiment itself. Okay, so yeah, any questions at this point?
So thank you, Kevin. There was one question from Lion Hong. Can you please explain a little bit more on how did the researchers obtain an overall representative sample with opt-in sampling while providing incentives for participants?
Yeah, so I mean, in one sense, it couldn't be fully representative because clearly there are some people who would never opt in, and any sample cannot include them. One question is how much that matters. And one way they got around this was by offering different levels of incentives to different people. So they offered people different amounts of money to participate. Um, and some people said that they would only participate for $1 million. And so the people who had said $1 million did not get to participate at all. And those people are not part of the sample. But that's a very small part of the population. And so instead, they're able to ensure that they are balanced in terms of the number of people who said they would do it for, $10 or $50, or in some cases, a few $100s. So they have some variation in terms of the willingness to participate. Again, there is some ceiling beyond which it's not possible to get those people, but it was a very small percentage of the people overall. And then they can check for representativeness on demographic dimensions like gender, race, and age. And so they could do that quite easily. Well, actually, I should say one caveat. Meta specifically does not collect information about race because US regulations make it very complicated if you have knowledge about the race and you are not being extra careful to prevent some kind of racial discrimination. So I don't think they did it on race, but they did it on age and gender and presumably some other characteristics about how people use the platform and their estimate of their partisanship and things like that. Okay, so that's the last case study. I will very quickly, talk about practical experiments, and then we'll conclude with a kind of like some practice in applying this formula, looking forward to a new type of experiment. So I mentioned the practical experiments at some point, and it's not really that relevant for academics. But in general, industry companies like Meta have the power to run a lot of different A/B tests. And perhaps that is something that some of you will do at some point. And so in general here, there's no theoretical interest. You just pick the treatment arm that performs the best. Clearly, that requires a lot of power in the world, this kind of ability to actually control things that we've been talking about throughout in the lecture. But even in this case, I want to emphasize that there are lots of issues with experimental design. If you don't care about the theory, you still need to make sure that things like the stimulus selection are balanced, that the sample makes sense given what you're studying, that your measurement is well constructed for the outcome variable. So even if you are more pragmatic than you are interested in theory, a lot of these concerns can come up. And so I just very briefly want to talk about a case study here that I worked on a few years ago. And so this is from Upworthy. So Upworthy, well, let's see here, right? The Upworthy was a company founded by Eli Parzer. Perhaps you remember it. Um, it was at one point extremely popular in online media. So they designed a number of basically media stories that were designed to go viral, that were also meaningful and awesome. So they were trying to go viral with positive stories. But they were kind of important in the history of online media because they were the fastest growing media site of all time at the time. And they pioneered the use of A/B testing to select their headlines, right? So one of the most important impacts of digital technology is the ability to listen. And so the ability for running A/B tests by corporations gives them a lot of power to figure out what kind of things to implement here. So they pioneered this new form of clickbait, where they had headlines that were, you can read some examples here. This amazing kid just died. What he left behind was one tacular. His first four sentences are interesting. The fifth blew my mind and made me a little sick. So these are headlines which are very clickbaity. They're not trying to tell you what the story is really about, but they're trying to entice you to click. And the way that they discovered what headlines were most successful was by running thousands of these A/B tests. So for every story they wrote 4 or 5 different headlines, and then they did an experiment for every single story to figure out which one was the highest in terms of the click-through rate. And so, the reason why I started working on this was we wanted to basically, there's not enough open source data about online field experiments. So, I mean, you can analyze the replication data that they give you from that Facebook experiment we just talked about, but that's just one experiment. And here we had a total of basically 30,000 experiments conducted by Upworthy that we were able to bring online for people to analyze. So I just want to, first of all, give you one example of a practical experiment that really, shaped the history of online media. And if you're interested in this more pragmatic kind of field experiments in social media, this is a resource where you can figure out how to learn from a large number of these experiments. So there's the Upworthy, I mean, yeah, there's all the data here. I don't want to spend too much time on this. I just wanted to point this out for people who might be interested in that type of result. Okay, so I guess there's 2 more questions here, and then we'll get to the final thing.
Yes, so there are 2 questions. Can you send your GitHub link to access metadata for the studies?
For the ones that are there, yes, I will do that.
Okay. And we didn't access data link or presentation PDF format. I'm not sure about that because we will send out presentations and recordings after the session. So,
Okay.
Yeah.
Good. And I'm happy to, I'm not sure that there's the replication files for all of them, but at least some of them I can definitely share. Okay, great. All right. So last 10 minutes here, we're going to think about applying this formula we've been learning about to a new context here. All right. Political influencers are, I think, one of the most interesting new forms of, I mean, they've been around for a while, but they're increasingly important for social media. And we don't really have very many good studies about their political impacts. So political influencers are people who are not affiliated with political institutions. They have high follower counts. They regularly post political content. They have strong engagement metrics. And so they are important because they can set the agenda for what people are talking about in online media. And they might also serve as intermediaries, kind of collecting the opinions of the masses and then bringing them to the attention of traditional political elites. So Right. Political influencers are people who are using these social media platforms. They often have some kind of important personal branding, or they have informal or provocative communication styles. And in contrast to, let's say, broadcast media, they're blending political commentary with lifestyle, humor, or entertainment. At this point, political influencers really span the political spectrum, but there is concern that they tend to, thus far, lean to the right, at least in the US, the context that I know the best. So I think that this is, the direction that social media, online media is going. So these political influencers are particularly relevant for younger demographics. They don't have the same accountability structures as traditional media. There's not a board of editors. There's not, an editor-in-chief. There's just individual people posting whatever they think of and whatever their audience wants to hear. And so we're seeing more of the attention and trust in the online media system move away from legacy media and political elites towards these online influencers. So I think they're going to be important for all of these phenomena that we are interested in terms of online politics. And oh, so yeah, I missed one slide. This is what I'd like to spend, let's say, just a few minutes thinking about. Where are you going to, like, how would you design an experiment to study political influencers? So taking this formula that we've developed, we'll think about what type of experiment we would want to run. So design process, field experiment versus survey experiment. That's kind of the first cut. And then for each of those, we have to ask, where are you getting your subjects? What theories are you testing? How do you have power to act in the world? How are you measuring the outcomes? And why is this ethical? I will give you two examples and then leave you to think about this, because I think this is an interesting area which we're going to see a lot more experiments about. I just came up with this off the top of my head here. An example survey experiment, right? So we have some mechanism that's theoretically interesting that is specific to influencers. So the role of authenticity, let's say, is important for influencers, and we want to understand how authenticity works. If we want to have a lot of experimental control, we could have a normal clip of the influencer giving their presentation versus a clip of the influencer doing a sponsored content, an advertisement with a label on the post saying this is sponsored content. And so the concern here is that people like influencers who are authentic, and there might be a punishment for influencers who are engaging in sponsored content with the label that they are doing so. And so what is a theoretically relevant outcome here? How does the audience evaluate the credibility of the influencer? Or maybe more interestingly, after we show them these two clips, does the message of the influencer, if the original clip was them trying to convince people, to change their opinion about some political issue, how does the effectiveness of the message decrease if you've also seen the influencer being inauthentic by posting sponsored content? In this case, the upside of the design is some tight experimental control that helps us understand how influencers work and why they are a particularly effective form of media entrepreneur. And an alternative, if we wanted to go for a field experiment, this is something that I have thought about, I think is quite exciting, is the capacity to collaborate with influencers to randomize some elements of their content. So influencers are, like Upworthy, basically their own independent media company. And many of them would like to know how to make their content more effective in some way. And I think that's something that we, as social scientists who understand experimental design, could actually help the influencers with. So we could, if we are collaborating with the influencer. We're figuring out what type of thing they're interested in, and we find some point of mutual agreement where they are interested in this thing because of their own purposes, and we're interested in this thing because of our theoretical goals. For example, we could encourage, the influencer could encourage people to donate to a political campaign or to an animal rescue campaign. And so we could see the difference in the effectiveness of these two types of campaigns. And this would be a kind of real life validation of the possibility of influencers driving behavior, but also the limits of influencers drive behavior. If they are more effective at getting people to donate to the animal campaign charity, this would demonstrate that influencers maybe are not that effective at moving the needle in terms of politics. Okay, so yeah, that's it for me. I encourage you all to think about how you would design an experiment to study influencers. This is, I think, an important area moving forward, as I said, and there's a lot of different experiments that could be done here. And yeah, I hope this has been interesting. And yeah, and thank you for sticking with me for these 4 hours. If there's any last questions, I'm happy to have a few more minutes here.
Yes, I think quite a lot of thank yous are rolling in from everyone.
Well, thanks you all for being here.
So I think since there's no more questions, I think we can start to close that session. So thank you everyone for joining us for this final workshop for the Data Science Summer School 2025. And first, a very big thank you to Dr. Kevin Munger for sharing his expertise and insights with us today, and for guiding us through the fascinating world of experimental design and digital media research. I think everyone has been quite curious about what's going on in this digital realm and how we can actually conduct research in this. And I think your sessions really help to open up some of the potential avenues on how people can start to look into this. And with your sessions, we officially closed the 2025 editions of the Data Science Summer School. And over the past 5 days, we've explored a wide range of topics from programming to mathematics and now experimental designs. And what I think unite all of these discussion is not just a technical skill, but also just the mindset of critical thinking, rigorous analysis, and also using data responsibly to address real world challenges. And so on behalf of the Hertie School Data Science Lab, I want to thank our instructors for your time and your dedications, and of course for all of you participants who are here today for your enthusiasms, your ideas, and also your willingness to learn from each other, and also for giving up the questions to the instructors as well. And I think this is what has made the summer school so special, is that all of us spending time together and learning something together. I think that's something that's really special. So we hope that you leave the sessions and also the summer school feeling inspired and connected, and also ready to take on whatever it is that you want to learn in your career and your path to know about data science and programming and AI and machine learning. And of course, stay in touch, keep learning, and we hope to see you again next year's summer school. We hope to also include other courses and other ideas and topics and subjects as well. And so after today, tomorrow, I will send out an email with all the materials from all the workshops, as well as how you can acquire your certificates, and also maybe how you can also put in your reviews and your testimonials, so you can suggest potential course for next year's edition of the summer school. Thank you very much, everyone, once again, and hope you enjoy the rest of your summer. Thank you, Kevin, for being our instructor for today.
Thank you. Thank you all. See you.
Take care, everyone.